by Professor Sam Olwinkle and architect Deepa Parekh. Before we proceed to our session today, we have a 2-minute slideshow on CIAT, its purpose and members. Kindly bear with me for just a second.
Architectural technology is a creative and innovative design discipline which integrates architecture, science, and engineering and focuses on
Ma'am?
Only folder is seen.
Whole folder is seen.
Ma'am, play the video and then share.
Yeah,
Play the
please.
video.
Okay. Just a second. No, it's actually a slideshow that automatically starts. Try once. Actually, I'm not able to share simultaneously. The windows occupying the full screen.
Is it the YouTube video? Is the YouTube video which is shared by Vidhu?
Actually, they have shared the presentation itself in the form of a video and a voiceover. So it's automatically starting as a video, which I'm not able to come into the Zoom window and share it. So if somebody from CIAT could help us with this at this moment.
Can I try to share now?
No, it's going to the, just a second, let me show. Please just bear with me. No, it's not working. Sir, you're on mute, sir.
We can do it in the end. We can start the program.
Okay. Meanwhile, I'll figure out a way to do it.
Yeah.
All right. Okay. Okay. We have with us today Dr. Mark Aurel Schnabel as the keynote speaker for this session. Dr. Mark is not a stranger to VSpark School of Architecture. Thank you for graciously accepting our invite yet again. Dr. Mark Aurel is the Dean of the Faculty of Architecture and Design, Professor in Architectural Technology at the School of Architecture, Victoria University of Wellington, New Zealand. Trained as an architect, he is leading research and education in the field of architectural technology. He taught and worked in Germany, Australia, and Hong Kong for over 25 years, and since then has become highly recognized for his work in the areas of computational design and learning environments. He publishes extensively internationally about novel perspectives in digital architecture and urban design. I'm extremely delighted to invite Dr. Mark to deliver the keynote address.
Wonderful. Thank you for having me today and be able to talk to you again. It's great to see familiar faces, and I'm really pleased to see that most of you are healthy and fit. It's great to see also the building in the background, which I'm very familiar with, and so I feel actually very connected. Maybe I start directly jumping into my presentation and share my screen. I got it there, here. I want to talk today a little bit, and I titled my presentation today about Geheimnis, which is a German word for secret. But there's a bit more a secret. It is basically also the urge of the discovery and the thing of, once you have that secret, actually of the sharing of this discovery and the knowledge. So it is not the idea of keeping, but it's actually the idea of sharing. So in this context, I want to frame my presentation. Now I just have to manage to get to the next slide. Yep. When I start my presentations, also I talk about this, that digital design and digital technologies is not a tool, but is a way about thinking of design. And I think this is very crucial to keep in mind if we work as architect in a more and more digital realm, that the realm is not only an instrument in which we execute certain things, like you would say a pencil, you could execute things, but it's much more how you engage with the technology and how you develop your thinking around, so that the technology can actually help you in the design process and can become the partner in the design. Also, that slogan, which was phrased by a software company, saying the change is everywhere, change is constant. And this is actually the problem which we face, that whatever we do, and there's the slightest critique, and even if we like, we always say, well, yeah, we can change it. So it's never finished. And it's also the situation of design. Design is never finished. Design is finished then when the deadline is, or we have to submit things. But now with the digital environment, we are actually forced even more to this edge of the constant change and the permanent and flux, which is very different to architecture. Once it's built, it is not changing, it's there. So we have that interesting dilemma that we want to build buildings which are actually flexible and changeable as we designed them in the same realm, in the virtual realm. Degas, a French philosopher, coined the term of the dualism, basically saying that the mind and the body are on the opposite spectrum of our human, but they all have their own identity, but they have to work together. With the mind, you can think something, but the body maybe requests the opposite. So, for example, if you want to be on a diet, that can be on a mental thing, but the body still requests that you eat. Now, the same thing, if you now translate that into when you now work in a computational environment, is you have a certain idea of how you want to have a design and how you want to develop it, but you have to deal with the machine, with the computer, to help you in the execution. And you can only do that what the computer can do for you, and you have to match that with what you think in your mind. This is a very interesting dualism. The realms in which we work is from on the right side reality, on the left side, on the right side the pure virtual environment, and we constantly navigating between the real and the virtual. In an architecture context, the output at the end, you could say, and that's how we live, how we engage, is really the real context. But to get there from your idea, which is virtual, over using different technologies, different simulation techniques, different knowledge and engagements, we constantly move actually in a more or less virtual augmented realm, so this continuum which is here presented. Now, if we look at this video, and I quickly just show the beginning, it is sort of a future vision of how we live in some future time, is where you see a person here on the floor and engaging in something, and you not really know what is happening here, but and you think it is a sports engagement. But what the person is wearing is basically contact lenses, which AR contact lenses, where he can see a very different world and engage in something very differently. So this person is actually playing a computer game and is fully immersed in this environment. That is very interesting in terms of being physically in reality and having here that environment in which he is, at the same time engaging very deeply in a world which is not there. And the same thing you can then expand a bit more as a future vision in terms of how your living environment will be structured where you can, with augmented reality, suddenly do a lot of things and give you information just in time when you need it. So the skill, the level of skill and expertise becomes suddenly something very different, because it does not necessarily sit in the expert hands anymore, because it can be translated to anybody using these technologies. So it becomes actually the idea of what the technologist does rather than and the person who develops the technology, rather than just being the knowledge of the expert. It continues in that way, and I can send you, if you want, the link to the full video. It's quite interesting story. I will show a little bit a project of what we did for the Ars Electronica. Ars Electronica is a very interesting festival. It combines art, technology, and society into a very large-scale event. It's in Austria. It brings people from around the world together to discuss and present of how technologies, culture, art can actually form together. And so the technology is not only there pure for the sake of the technology building and so on, but it's also goes into an artistic expression. That was the topic. And because of COVID, the Ars Electronica was done differently, meaning it was all virtual, and there were a lot around the world satellites which presented their artwork, and it was streamed together around the world. Now, we presented the garden from New Zealand, obviously, because I am now here in New Zealand, and you see here a little bit a shot of an island very nearby Wellington. And what we built there was you could say, a digital twin. On one hand, on the bottom, you see the physical exhibition, which is actually was here in New Zealand, but it is superimposed with a virtual exhibition on top of it. So you have the place where you go, where you can touch and feel what you see, but at the same time, you have the superimposing of a virtual environment and a virtual context. And you can experience both of it, while the people remotely could only experience the virtual context. That is how it basically comes together then. And I just click through this a little bit. So was then the virtual layout of the different work which we put in there, and I will present a couple of these ones. So you see now here, these are sort of the project spaces which you could go through. The first one was a work, The Architecture of the Sea, and we were there interested in how actually the space under the water is organized and presented. New Zealand, surrounded by water and a lot of rain, it is a very crucial element, and really a part of what the New Zealand identity and culture is. So we looked into what are the spaces which air, which water does under in that context, but on a very micro scale. And that was quite interesting to see of what are the definition of space in a very small scale in water where you have liquid, to understand a different realm and see how that can inform us of spaces which we can then inhabit. And we put together this virtual exhibition space, as you can see, with now the different artworks in kind of a gallery space. And it is the concept of it is that you can go and you can experience the artwork in a multi-dimension, in terms of there was art, there was poetry, there was some of the movies which you just saw, there was sound clips where somebody is reading and you hear things, and the space is laid out as such that you can individually go through like as if it's in a real gallery. But at the other time, because it's a virtual environment, it allows you to do things very differently. So the materiality is very different. The thickness of wall is different. You can go through walls. You can see from one space to the other. And that was the idea to play what a architectural definition could be in a VR, relating to reality, but having still its own expression. If I go now to the next project, it is where we looked into eye tracking, and this is a virtual space, and we let people go through an urban design, an urban context, and actually tracked where people look at, what they take as reference for navigation, and how they navigate through a space. This allows us to actually quantify and justify why certain things are or why they not are, and how they work or where they not work. So it is actually an interesting tool to see that an architecture or design which one builds works in a certain way, and it is not just an assumption that how a space is perceived and used, because you can really track of how people use it and what are the visual elements which are important for people, not only in terms of the navigation, but in terms of the experience of the space. You see here the little cubes which were generated and arrays, so you could play this whole thing again and understand where the color was changing if people looked longer at a certain time and so on. And you could, by that, then have a very detailed analysis of the environment and the experience of that person who went through that space. Here, this is just another one. So the person who uses space does not see the voxels to happen, so it's not really disturbed by it. But then once you have it in your analyzing phase, you can see that. And by that, you can understand how a city is used, how certain buildings are used, and how you can actually design an urban context in a way that it can function well. Here it's just another sample. You see on the left side the tracking of the person, and on the right side you see how where the people look at and what they experience in this place. Good, I go to the next one. Now, I also have that quote here. We all often talk about the Internet of Things, and that becomes as kind of established term. But I thought it is actually also very gadget driven, and it's not architectural. It's technology driven, but not human driven. As human, we walk through spaces, we experience spaces, and it is important that we interact within the space, and technology also has to interact in that space. So looking in that one was you find in the city typical kind of information displays where a person wants to find a context where to go, and you see a little map in there and certain directions. Sometimes it's very difficult for people who are not able to read maps or understand maps as architects, urban designers do, to really understand of how you navigate through a space. So in that context, we looked at, can we have an AR map, even a Google map for people walking, can work, but can also be difficult to really fully understand. Can we make that map much more experienceable in a three-dimensional space, in something which people used to when they go through the city? And instead of saying you go now right and left and follow a line on a map, we basically placed markers, big visual markers in a context, so that people know where they go. They can see this is the direction, but they can now navigate their way through to get there through the city, and they don't need to look at the map. They just see the general direction, and then they will arrive at that point. That allows really a very different navigation system, because it's not directed by a path or the shorted path, but it's directed by an experience. And I can still be part of a city, and I can see what is a shop, what is the environment, and can see people. And once in a while, I can just check my direction that I'm still in the going to the right path. Now, if we translate that a little bit more into a more abstract context, is how can we bring in sensory experience into a virtual environment, and how does that one inform us then what are sensual experiences in reality? So it is crucial to understand the reflection of what is real, what is virtual, and what virtual can then inform us in a real context. So we generated that more abstract environment, and we have a puppeteer who holds the object, which is tracked in the virtual environment, and it seems to be alive. There are certain elements, you have a certain touch and feel to it, you feel a quality to it, it reacts with sound, and there's smell, and we can smell the things, it emits smells. So it becomes an object which is in VR live, and it takes away the pure focus on the visual, but it becomes a multisensory experience through the spatialized sound, through the smell, through the touch, and your own body movement through a space. So we have another exhibition space which relate more what I talked about, the Geheimnis, where we put different objects in there and different experiences. One is about the glitch, and I presented it, I think, earlier. It is about the computer glitch, a very interesting phenomenon of a file, of a situation where the computer cannot deal with the information in the way of it, how it used to, and it gives us information which is very difficult for us to interact. So the pure information is still there, but the legibility of the computer and the legibility of us humans suddenly break down, and it's this interesting moment of the breakdown of communication. And you have here that space where you can now go through the different environments, understand what it is, it's explained there, and you can then enter each of these virtual experiences. And I jump over this one, just go here to this one, which is a building in Hong Kong, the Hong Kong Walled City. It's a very famous, was a very famous hyperdense environment where people lived and never left the building. It was a huge complex in really multidimensional in terms of expression and the living form. And this experience tried to regenerate the architecture, the spaces within there, which was, because it was so huge, was not orientated through conventional architecture with window, facade, and so on. It was all this spaces within, with had some lights, some no lights, in different pockets of where people interacted and lived. And so it was, this work is a recreation of it, but at the same time, a current interpretation of a space which relates to the medium of how you experience it. So if you experience it in VR, it's a different one than if you experience it in reality. And hence, there are certain elements to superimposed on the real experience to really relate and explain the dualism between the real and the virtual experience, being the real not existing anymore because it's taken down, and the virtual being here real, but it is now it has evolved, as the Kowloon Walled City also has evolved over many years so that it's not just a reflection of what was, but it is a living organism. Again, the eye tracking is a topic which we explored a bit more, and saying, can we do with the eye tracking not only track how we look, but can we use the sense, the eye, also as an instrument to generate forms? And what you see here is it's a tracking of the eye, that's a white ball, but at the same time it generates the form. So the eye is not only a one-way consuming of the visual information, it actually also generates visual information. So you invert a sense which is conventionally only a one-way into a two-way sense. And that is a very unique thing, that the eye becoming the creator and the perceiver. So you do at the same time as what you see and generate. And that is a very interesting, you could say, mental workload on the eye and your brain, because you suddenly use your own senses in a completely inverse way, and you can generate something where you are not aware that you could do this. And that is here in the initial stage of our development, and we refine that so that you can actually do more. It obviously needs some training. The same thing as a piano also needs training to operate if you want to operate well. But after a little while, you'll be actually quite good in doing that. So coming a little bit more back to an architectural context here is that work where we have in an urban context, we have markers, and you have library elements of an urban design, urban context. And by moving these together, you can now generate new forms. And that is a way of how you can engage very simple with layperson who have no architectural context and understanding to have a conversation about urban design and urban context. So you have different elements, you put them together, and you can by that define how do you orientate a building, what are elements which you want to have in terms of garden, in terms of the size of your building, and so on. Sure, as an architect, you generate the elements in the first place, and then as a user, you can then can explore that in a very different way. And again, the exploration for the user, making a tool very easy, accessible. Again, you are in VR, you don't really know how to use a CAD software, but by using very simple techniques and operations, you can generate form in a perceived one-to-one environment. So you build your space in a one-to-one scale, so you can really relate to what you do, how your body sits within that space, what is the expression in there, and you can design something very quickly. Now, what you see here is not yet architecture, but it's a definition of space, and it is something where people can learn, understand of how you want to do something, and that is it acts as a starting point then with architects to translate that into more architectural context. And here again, that is the same thing now applied really in an urban design context, where we worked with the Urban Council to generate here a design proposal for a scenario in Wellington with people, with residents there who normally do not design anything, have no context understanding of urban design, but were actually suddenly able to engage, to define what is happening in their urban environment, in their own neighborhood, and could by that communicate that to the council to say, this is what we want, this is what we don't want, because they were the active players in this process and understand the context and the difficulties and the challenges of something like that. How are we time? We still have some minutes. Are we running Okay.
Yeah, a couple of minutes, Dr. Mark.
All right, wonderful. I slowly wrap up. So I just another project, and it was about the idea of sacredness. So if you are in a real building and you in a church, in a temple, in a mosque, any place of faith, there is a certain architecture which allows you, and where people understand, I am now in this place. And you have certain rituals which you do to practice your religion. But at the same time, if you now come to a more abstract environment, let's say the virtual reality, or let's say you go on the International Space Station, or you travel to Mars and so on, where suddenly the context is not available, the architecture is not available, how can you then practice space, your faith, and how do you can perceive that environment? And we explored that here in the context of an Islamic belief, where you have certain rituals which are fundamental to the practice, and it's from the calling to of the prayer, it is from the washing of the hands, and it's also that the bowing towards Mecca. Now in VR, there is no Mecca, there is no direction. In VR, you don't have water. So how can you now translate these, that they are unique to the experience of VR? It's not a false copy, but it becomes something which is that what it a believable context, what it wants to be. And here we tried certain things. There are definitely personal ideas and expression of how it could be. It is not really the solution of it, but it is an engagement with a topic, with a field where we have not yet really engaged this architect, and see how can we actually engage in an area which is completely new to us, but which is important to explore and to understand. So that's the interesting part of how you generate space, how you dissolve space, how you generate a place of being somewhere, and at the same time not to be too literal and a copy of reality. And it can then go even more abstract, okay, that we had that already here, where you say, if we now totally dissolve and say we are in a virtual environment, in pure virtuality, where you do not respond to the physics of reality, how you define now materiality, space, and so on. And this is a very abstract interpretation to generate an spatial quality, and which is not a copy of a real scenario, but becomes in its own right an entity in this context. All right, good. Where are we? This work is now coming back to more reality. It puts in a very interesting story. Say, now can we actually generate, can we use 3D printing, can we generate forms which are real forms, which are sort of organism? And I told you at the beginning the context of the water and New Zealand, but have expressions which can relate to that, but which are physical, which are not virtual. They are virtual in terms of its expression in form, because they are not existing and it's not a copy of a real organism or plant, but we generate something which has its definition in the realm of which we are living, but it's a completely artificial a representation thing, but it's a physical thing. It's 3D printed. There's a touch and feel to it. You can see that, and it's all generated obviously digitally through the machine, and come to that outcome that what you see here. break that here. I show here quickly the team. What you saw there is not only done by me, that is in our research lab at the School of Architecture here in Wellington. With my colleagues, we have a team of PhD students, master students. We work with other universities together and developing obviously now closer relationship with VIT, and that's something which we really look forward to, and I believe that would be really exciting, and to bring ideas which we have and merge this together of how you operate and how things are with you. Thank you very much.
Thank you so much, Dr. Mark, for that terrific presentation. I now request everyone to please allow me to try sharing the CIIT video yet again. I just
Architectural technology is a creative and innovative design discipline which integrates architecture, science, technology, and engineering, and focuses on performance and buildability in design. Architectural technology encompasses a range of different specialisms, including conservation, sustainability, BIM, environmentalism, fire safety, and many more. Technology is leading the change in the built environment sector, and the Chartered Architectural Technologist is the professional with the skills necessary to drive this change. The Chartered Institute of Architectural Technologists, or CIAT, is the qualifying body for the professional qualification and protected title of Chartered Architectural Technologist. It is a not-for-profit organisation which sets and maintains the standards of education, practice, and professionalism in architectural technology by awarding professional qualifications, applying its code of conduct, ensuring members undertake continuing professional development, and accrediting qualifications in higher education. Those studying and working in the field of architectural technology and related areas are eligible to join CIAT. Benefits of joining and qualifying with CIAT include having a global voice to represent you, professional recognition, access to CPD events, professional and social networking, mentoring, and more, which can be found on architecturaltechnology.com. We offer an international subscription rate to those based outside the UK and Ireland, and these rates are shown on the slide. We recommend you take a photo of this to consider later. Student membership is free for the duration of your course. For more information, please visit the website for the requirements or email international@ciat.global. Global demand for architectural technology professionals is increasing all the time, and employment opportunities are growing. CIAT is working hard to develop its international network for its members and its collaboration with similar organizations worldwide. Please follow CIAT on its social media platforms. And for more information, please contact CIAT's international department at international@ciat.global. Thank you.
thank you, CIAT, for partnering with us in conducting this international webinar. We are now beginning the presentations by our panelists. The first presenter for today is Dr. Molay Jalal. Dr. Molay Jalal is a senior lecturer in architectural technology and the course leader for the MSc Digital Architecture and Construction at Nottingham Trent University, UK. Molay is also actively involved in various research projects in the Creative and Virtual Technologies Research Lab at Nottingham Trent University. His research centers upon areas like urban energy planning support systems, energy planning and public engagement, building information modeling, application of algorithmic design principles in architecture and urban design, and innovative visualization techniques and digital design models and processes. Dr. Molay, you may please begin your presentation.
Hello, good morning or good afternoon, depending on where you are. First of all, thanks for this opportunity to present my work. I'm just going to share my screen. Don't know if you can see it. Do you see my slides? Can anyone tell me if you can see my slides?
I see the slides. Very good. Thank you.
Thank you so much. I'm going to present our work entitled From Discovering to Delivering, a critical reflection on eco-feedback, application design, and participatory research in the United Kingdom. As you already know, there has been an increase in pressure on local governments worldwide to cut their CO2 emissions in order to protect the environment. In the case of the UK, the country is responsible for cutting down its carbon footprint by 100% by the year 2050, and that's counting from the year 1991. In order to meet such targets, several measures have been implemented, majority of which revolve around improving the thermal and the physical characteristics of the building envelope. However, since 70% of the residential sector in the UK has been prone to retrofitting measures, which are basically part of physical measures, the application or the implementation of such measures in the long term might be not the most effective. And I'm talking from building performance point of view and cost point of view. And that's why you see recently other scholars and practitioners in this area exploring different alternative measures, some of which target the behavior aspect of the users, claiming that, and certainly, the cutting down the carbon footprint is not the responsibility of the government only. It's indeed everyone's responsibility in the society. So part of the behavioral measures that have been explored recently is an area called eco-feedback. So what is an eco-feedback? An eco-feedback is a system, either hardware and or software, that provide building occupants, known as end users in this field, with useful information about their present and historical energy information. There are some applications as well, eco-feedback application or system that provide some tips to the users in order for them to further improve their energy efficiency. While the implementation of eco-feedback has been proven by many studies to lead to savings in the region of 10 to 15%, there is a common problem with those systems, is that their effectivity decay over time. In other words, such application or systems struggle to maintain end users or building occupants in long-term pro-environmental behavior. And part of this problem is that this application initially used smart meter infrastructure and were implemented mainly at the household level. And that's why you see in the last 5 to 7 years, researchers are less talking about individual eco-feedback systems, but they are mainly start to shift towards more community-based eco-feedback systems. These systems certainly use some well-known technique from social and environmental psychology, and these are competition where they gather end users from same community and they promote some sort of competition based on the most efficient user in the area. Certainly, this can be coupled with comparison. If you talk about competition, you usually talk about comparison measures. Either you compare to the most effective or most efficient user in the area, or you compare to the average user in the area. And of course, certain application community-based, they use what's called ranking measures using leaderboards, and others, they use reward systems, either monetary or non-monetary. While we explored the literature, looked at the trends and the gaps, we found a major gap with regards to community-based systems, is that none of the studies actually involve the end users in the design process of such application, of such systems. Yes, they do involve them when they want to implement, or they will while implementing and deploying the application or the system. but they don't involve them in the design process. So which made us wonder if these systems are tailored to help end users save energy and promote a sense of community, why then they are not considering their involvement in the design process. And based on that, our aim of this study was to develop a participatory eco-feedback, community-based eco-feedback system, which involves the end users from the beginning, early design stages throughout all the process until the deployment, and why not post implementation. In order to achieve this, we have utilized a very well-known participatory participatory design framework, which is called a double diamond framework, which was, of course, developed by the UK Design Council in 2015. This framework is characterized by the occurrence of divergent and convergent thinking. These two processes occur throughout two stages, resulting in this double diamond shape. Divergent thinking consists in a nutshell of getting an insight into the wider context of the problem or the subject matter, whereas convergent thinking consists of refining those insights and coming up with a practical solution to the problem. In the case of our work, we have adopted 4 stages of implementation. In the first phase, we wanted to explore the opinion and the preferences of the wider population about eco-feedback systems. For that, we have conducted a survey questionnaire. Once we have done that, in the second stage, we analyzed the data coming from the survey, and we developed a design brief, a concrete design brief. In phase 3, we have organized participatory focus groups at Nottingham Trent University, inviting members of the community. What we have done in the workshops, we have delivered presentation about the project, and we gave them the design brief that was developed on the basis of the survey questionnaire. After we analyzed the data and the designs that came up in the focus groups, what we have done is we try to develop a consensual eco-feedback interface that we want to deliver. So this is the phase 1. Phase 1, of course, the survey questionnaire. What we have done, the themes that came in the survey were based on a literature review that was conducted previously and included things like that: familiarity with information technology, eco-feedback technology preferences. So we asked things like what type of eco-feedback application you prefer. Would you like a web version, a smartphone version? Would you like a physical version even? And so on. We asked them about privacy because that was a common theme in this area. So we wanted them to give us their opinion about data sharing and knowing, and even we asked them about whether they mind visualizing data on maps. Another problem that came in the literature is social interaction. Some people don't like competition, and they found this will lead to feeling under pressure or feeling maybe some sadness. So that's why we try to ask the participants or the wider population about those aspects. Finally, we ask about what type of information they want to appear in this eco-feedback system. And of course, we ask some demographic questions just to make some correlations. The survey was disseminated in the UK. We used a service called JISC, and we got the following 151 participants or surveyees. Overall, there we had a good distribution for their age and gender. However, if you notice, we have a high proportion of people aged between 25 and 44, and that's because the JISC service have used mainly their social media platform to disseminate the survey, which explains that distribution. It is worth mentioning that the aim of this study was not to generalize onto the wider population, so that did not matter so much, but it was mainly to get an insight into the wider audience preferences. These are some answers, key answers from the survey. Of course, the survey has got 15 questions. I'm just showing the main ones. So the participants, a majority of them wanted a smartphone application of the eco-feedback system, whereas 9.1 wanted a web version integrated in social media, and that could be a sign of privacy concerns amongst the surveyees. As for data sharing preferences, the majority didn't mind sharing and knowing the data, energy data of others in the community. However, 9.3% said they didn't want to know and share. So looking at that distribution, we thought we should give the users control over the data sharing preferences in the eco-feedback system, just to give them some reassurance. On the right-hand side, you can see that participants wanted to know about different type of data, including aggregates, energy information, and disaggregates. Aggregates can include the overall energy amount in kilowatt per hour, the cost of energy. Disaggregate energy is the appliances, the use of appliances, and so on, the rating, etc. So in phase 2, of course, we analyzed survey data and we developed a design brief. In a nutshell, this is what the design brief included. The eco-feedback system should be developed in smartphone version with a portrait orientation. As I was saying early on, we should allow the end users to be in full control over their data privacy, data sharing preferences. The interface that we're developing should give users equal suggestions and tips as long as they do not affect their comfort levels. Participants also wanted to know about not just electricity and gas consumption, but they wanted to know about water usage. Certainly, they wanted to know about different types of information. There were some comments as well about off-peak tariff. And finally, they didn't mind those techniques, comparison, ranking, and reward. So these are images from the workshops that we hosted in Nottingham Trent University. We had 2 focus groups where 10 participants attended in each. In the first focus groups, we had 2 interfaces developed, and of course we went through several iterations. So in that case, we had 8 iterations in the first focus groups. Interestingly, in the second focus group, the participant didn't want to work in groups. They wanted to work in one group and develop one interface. And that interface development went through 4 different iterations. Just on a side note, we have used paper prototypes instead of digital means, just to speed up the process, to allow more flexibility and to be more inclusive of those who are not familiar with technology. These are the interfaces that came up, the 3 interfaces from the focus groups. In general, they had similarities and differences. For example, if you look at interface 1, 2, and 3, all the participants wanted a menu bar on the top with some minor differences. For example, interface 1, they wanted to know, they wanted a profile button, notification button, and they wanted some settings. However, in interface 2, in their first panel, they wanted a status bar, just showing their energy consumption in a color-coded fashion. So if they are green, that shows them they are consuming less energy than the average user in the area. If red, then it's using, obviously, consuming high energy than the average user in the area. In panel 2, majority of them, except interface 2, they wanted to know, to get like aggregate energy information, just the cost of energy and the overall energy in kilowatt per hour. And for interface 2, they wanted something different. They wanted a community space where they can find out about what others have done to save energy, what they're ranking, what is the winner of the month, and the reward, and who has won the reward for that month. In panel 3, in all interfaces, participants wanted to know detailed information, disaggregate information, in other words, including appliances, etc., monthly usage, and so on. Interface 1, interestingly, in panel 4, they wanted to get some suggestions, and in their 5th panel, they wanted to have a map 2D map, just showing the energy consumption of community members in the area. Interface 2, on the other hand, in their final panel, they wanted a 3D map instead of a 2D map because they claim 3D map are more clearer, and they perceive them better in a better way than 2D maps. In the final interface, something really interesting came up, is that participants said we want the interface to be as light as possible. And they only wanted to get the overall energy usage in kilowatt per hour. In numbers, because they said numbers are more effective than colors. Of course, what you see in interface 3 is the mapping of all the features when you extend different tabs. But initially, they want it to be very simple. And if you want to get more information, you can click on certain tabs and expand and get more information. The participants working on interface 3, they said we should give the users options for using either 2D and 3D maps. In addition to the design, there were some interesting suggestions that came about. So, for example, some participants were really concerned about their privacy. They said, we don't like the idea of showing energy usage on the building level. So instead, as a measure, we thought, why not showing as a rough spatial resolution at the block level instead of the building level. At least in that way, we can protect their privacy. Another suggestions that came about as well is that some participants said, if I'm consuming high energy and other users can look at me and know I'm consuming high energy, I can feel a little bit of pressure and stress and feel obliged maybe to save energy. So we thought, why not by using pseudonyms instead of the actual names, just to protect, keep their information secret and solve that problem. Other people said they don't want to work with their neighbors in the community. They prefer instead to form communities with their friends, with their social networks, such as friends. And we opted for an option in the system where you can send an invitation to the users that you would like to be in their community. And the user who received your invitation can then either accept or refuse. But when they accept, they have the option as well to allow what type of information they would like to share with you or not. And another interesting suggestion is that users, some participants said, people don't really use this application on a daily basis, especially if they are busy. And they advise that we should opt for a multi-purpose application where you can integrate, for example, a feature to pay their energy bills in the application. So you visit the application, you don't just look at your energy usage, but you have an option to pay your bills and maybe look at the energy tariff and compare different energy tariff, and you can switch your energy provider. So in phase 4, we looked at those suggestions, those design, and we developed the following eco-feedback interface. So the interface upon its launch, as shown in figure 11, we should have a very light application environment showing just an indication of your performance using color coding system and a smiley feature. And of course, some numerical indication. For example, if you're consuming less than the average user in the community, should have a minus and the color, and you have a smiley there and a green color. If you are consuming high, that will change as well. If you are consuming on part with the average user, you should have a number color coding, and it will be the number will be plus minus 0, 0. In the second panel, there are other usage as well for gas, electricity, and water as requested by the participants. There is a community space button there, which will take you to the community space, which I'm going to talk about later on. And if you want to expand and look at your detailed energy consumption to better understand and maybe correlate with the weather pattern or your presence at home, etc., you need to click on those buttons. And as you see in figure 12, that's the full interface with all the information. So for example, detailed information about consumption can include the energy used by HVAC system, by different appliances, etc., or by fuel, or per day, per temperature, etc. Below, there are some suggestions that you can check in order to save some energy, and there are even some external links to some governmental grant, maybe to upgrade your HVAC system, etc. And below there is a map which allow the participants to look at, to get an idea. Of course, it's not detailed per building level, but it's at the block level where they can look at the energy usage in the area. And they can switch between the 2D and 3D map. The community space is composed as follows. We have newsfeed showing what's going on in the community. There is an option as well for the user to publish an energy saving actions they have made recently. And there is below it, there is a ranking option here where you can see the ranking of the users. The most efficient user will have a green medal next to it, next to him or her. If you hover over the user, you should be able to see the 3 latest actions they've made to save energy. And if you want to find out more, and maybe the actions were not clear, or maybe you want to find out more, you can double click on the user and you can start a chat function with them. So that's all for the participatory eco-feedback community-based system. And thanks very much for your attention.
Thank you so much, Dr. Molle. It's a great initiative on bringing energy monitoring and conservation strategies in our everyday lives with the eco-feedback system. So the next presentation is by architect Varun Totem. Architect Varun is an architect and builder, ecological building and design consultant, a trainer and researcher. He brings more than a decade of experience working in the USA, Canada, Mexico, and India. His interest areas are permaculture, bioclimatic architecture, rammed earth, cob, wattle and daub, stone masonry, vaults and domes, natural plasters and finishes with lime and earth. His current research explores the work of traditional artisans in India, their didactics, ways and methods of designing and building. I invite architect Varun Totem to begin his presentation. I also, so just a minute, Varun, I also request all the panelists to please stick on to the 15-minute time that's given to you. Thank you. Varun, you may please begin.
All right. Thank you, Deepika. Thank you, Jacob, for this wonderful invitation. I hope you can take a look. Are you able to see my screen? I've just started sharing my screen. I'm going to start with a very simple slideshow. So my essential presentation is very foundational. It is.
Sorry to stop you. We are seeing your folders, the images.
Okay. I will new share and I will share this. How about now?
Yes. Yeah.
Yes,
now
we can.
Right. So essentially, my questions are very foundational. They're questioning technology and the approach, the philosophy behind it. I'm using the idea of human Purusha in Indian architecture, where man is not considered as a human being alone, but it is also considered as his relationship with the cosmos. And essentially, what the first speaker also talked about is that there's only something that is constant, that is change. And that the environment around us, the context around us is constantly changing. The conditions of living are always changing. Whereas man and the human body, the soul, is something that has not changed and that is relatively constant. Essentially, man's preoccupation is his relationship with the context, where one is fixed and the other is changing. So the adaptability of human beings to this changing context becomes the central idea of any endeavor, whether it be food or shelter, architecture, whatever it is. So I've kind of drawn out 7 central questions from my own design build practice. And I'm going to look at the dichotomy or the complete spectrum of solutions that have been possible in these central questions. And I base myself starting off with the first question, that is tradition or innovation as a foundation for exploration, right? So John Jandai said, very famously in one of his TED Talks that a rat is able to make a home in 2 or 3 days, and a bird is able to build its nest in a week. And why do we human beings have to spend 25 years on a mortgage to be able to own shelter? And why is it, and how do we call technology actually helping us if we are enslaved to this system of having shelter or just housing? And then if you look at India as a very nice example, you have several communities, several cities where humans have really built like a single species, like how a rat builds its own home. There's not too much diversity of aspirations. There is not too much diversity in ethics. They all cling to the same central idea. And houses do resemble each other. The materials do resemble each other. And there are a lot of learnings in this tradition. Of course, if technology is able to reach back to this tradition, then we are on firmer ground. Because if we are looking to diverge from this and walk away, then we are walking into a blind future, because we are always racing in a straight line rather coming down to the center of a circle. So you can see in this example where the material is the same, whereas the technology to use the same very local material has changed. This was rough cut stone in the 1500s. This was human cut slabs with little advanced tools in the 17th or 1800s. And now you have perfectly machine cut blocks. It's still the same material, right? So in my travels through Mexico and Latin America, I've probably spent 6 years as an apprentice of two master masons. And traveling around has pretty much enlightened my architectural practice and the way I look at things. I do understand that predominantly the major part of housing and buildings is still done by people with their own very hands. And it does not require a formal architect or an engineer to build their own houses. And they are the ones who are actually facing the larger questions of construction, constructability, buildability, efficiency, ecological questions, whether the ethics of building, the efficiency, economy, elegance, everything that David Billington had really written down in his paper. And if I'm just trying to use, because I can speak about several technologies or techniques that are very vernacular from different parts of the world, essentially using local building materials. But I'm just going to use one built form or one building method or one building technique. That is the art of building a roof or a structure with mud or with in the shape called vaults and domes that we talk about. Very curved structures. You can look at this oven bird, which every year tries and builds its own house with just mud. And it's a uniform monolithic structure with one single material. And it does it year and over again without without even questioning the form, and is able to do this with a lot of structural innovation, of course, for us human beings. So some of my work in Mexico was to have a design build studio with Tecnológico de Monterrey. And with my students, we would look at this question of traditional innovation. And the innovative way was, of course, to use computer tools, whether it is SketchUp or AutoCAD, to look at a certain set of curves. And of course, use those curves to develop a built form, of course, develop a formwork and so on. And we were always trying to test how would these local traditional building materials fit into this form finding methods that we were trying to look at through technology. And every time we realized that the need for being very precise, being very accurate with shapes and forms was limiting the use of our traditional building materials. And we saw that the traditional methods actually did not need too much of form finding or innovation. There was a lot of tradition involved. There are a lot of methods that were already proven and worked out, right? So This is a studio, a 3-month studio project where students would work hands-on with Adobe bricks made from the very mud and do a very thin vaulted structure with the students. So my second, my other projects, for example, also involve the same similar form, where I used this Adobe brick and trying to create structures of this form with this form, right? And most of the time, it was very easy to get people to work with these materials, because I just felt that these materials or these forms are somehow a part of our own human self, just like how an ovenbird is able to build its own house without any practical training or experience. I just found just working with mud is something that we have within ourselves, and that cannot be contested, neither can it be easily proved. So these are, for example, again, Adobe bricks made, and we make these very interesting build forms. This is one of the projects that we had finished out, right? It's all simple mud, waterproofed with a fired brick, and built from materials from that very site. The second question is about rational or intuitive design. So I started my career at the Oroville Earth Institute, where they really teach a lot of rational methods of form finding or stabilizing vaults and domes, analysis of masonry, the graphical analysis, computational form finding and design, and so on. And I, of course, over time, I just felt myself to be very limited with these methods as I started looking at, the works done by Andres Flores and James Anthony in Mexico, where none of these rational computational methods were actually used. And it was the intuition, the human body and its understanding, a relationship with these building materials, which actually came into place. And here, for example, you can see vaults and domes being built by students for the very first time in their lives, where they haven't even placed a brick, but they're able to build these forms with the human body as a measure, as an intuitive way, learning balance and repose of bricks, learning the strength of mortars, and just guiding curves with their body. It's a sensation, right? So these are, for example, different workshops where we are working with intuition. And the beauty of it is that when you are using intuition, you are able to connect. You do not need a guide. You do not need rules and regulations to have this form in place. You are all connected in a certain intuition, which is working for you as a human being. That is how ants are able to build an ant hill without much communication. So this is, for example, a workshop, where very quickly we are able to build just through intuition a vault or a dome. As a finishing of a vault or a dome, you can see that these are just architecture students. Of course, as I traveled through Latin America, I saw several non-architects, non-builders, just building their homes with a very variety of shapes and forms. And I was really excited to see how beautifully, with simple intuition, that these forms were actually achieved. And a lot of this intuition, of course, comes with an observation of nature. It is biomimicry at its core. And it is not a rational breaking down of what is seen biologically. It is something that you feel and you understand. And when you do it is when you understand. Now, my other question is, whether we're trying to work with something that is stronger or weaker. So typically I've seen that our technologies have just been directing us to stronger building materials. And somehow over the time, I've learned that it is not the right direction to take, because anything that is strong will be very rigid and will crack easily on an extensive application of force or something that is unexpected, which is very common in change. Whereas something that's weak will always just bend and not crack. And that is why it is more resilient in an earthquake zone or in a cyclone or a storm or whatnot. So it is not strength that we are looking for in building materials, and especially true for a country like us, where we are trying to just use the bare minimum resources and share to be able to build. More strength means more energy, more intensive technology, a lot of more quality control, and of course, a lot more cost. And it is directly, leading to something that is very nonsensical. This, for example, is a very urban site where we just, used very simple mud, soaked and then dried out on the very road, the main road. And we blocked the main road and used these blocks to create this kind of a built structure. It is just simply sun-dried bricks, right? Now, if I'm starting to use just mud, and I understand that it is definitely a weaker material, but the advantages with that is that it requires lesser skill. Because skill is something that you normally work with the use of a tool. Because if you have a tool, then you have to learn a tool, to the use of a tool to develop a skill. Working with mud is just working with your own hands. And the agility of using your own hands is something that you've already learned throughout your life. And hence, using mud also breaks away this barrier of skill. And similarly, it breaks away the barrier of gender, of race, of abilities, of experience, and so on. And here, for example, you can see some very nice workshops of students just working together with very little supervision, and and they're able to build up a roof on top of their own heads. It's very powerful. This experience of being able to do something with your own hands, because now it becomes a part of you and nobody can take it away from you. Nobody can race you against it, right? Whereas using something that is, very technology driven is something that can be easily, that can basically outdate you very easily, because it is always going in a straight line. Right. So now coming down to low cost or high quality, just go to plastic or non-plastic. So when you look at non-plastic, what I mean by non-plastic is very rigid straight line derived structures. These straight line derived structures, just like Hassan Fatih says, the straight is a line of a duty, whereas a curve is a line of beauty. Plastic structures are basically moldable, malleable, hand-driven, intuitive-driven, where you do not have a rigidity of a certain direction. It is something that is very soft and malleable. You can develop a form with the way you want it to be, right? And it is in that malleability that you find the beauty of fixability, because what is non-plastic, what is very rigid, cannot be easily fixed. It has to be discarded. For example, if you look at a plastic bottle, which is very non-plastic, because it is a very rigid piece, a plastic PET bottle. If you have a small hole in it, it cannot be fixed. It just has to be discarded and hence becomes waste. Whereas if you have a very plastic, moldable form, like a mud pot, right? Then of course, you can always fix it. You can use it again and again. And that is why traditional techniques and technologies are heavily ridden with a lot of plastic forms. This, for example, is again the use of all these plastic moldable, malleable forms, which can be easily fixed. Now, the beauty of the question of low cost or high quality directly starts coming in, because I just spoke about cost. This, for example, is the rebuilding of a school roof somewhere in Michoacan, Mexico, where just after the 2014 earthquake, their school roof had fallen down and the students wanted to build their own roof. And we very easily engaged 13, 14-year-olds into the act of building their own school roof. And it was very easy to transfer that within a roof, they were able to build their own school roof. It's a very powerful idea. Of course, this also happened in the Cuckoo School in Javadu Hills, where a community started coming together to build a certain school, right? These are all workshops, of course, showing the power and the ability of using these forms, right? Now, a question of the one that next comes together is the community or the individual. See, most of our design practices really rotate around an individual, and the ability of using mud gives you, the power to work with the community and reach out. That is basically making you a lot more relevant in this world. That means that you are going to run a practice or gain skills or gain experience that is useful in this world and not just limited to a certain individual. And for example, here we have some really large scale walls and domes being built by through workshops where a community is being engaged to build very simply with mud. It's very simple tools, guides, very simple methods to be used, right? And now, these are all photos from that same workshop and a building, a project. A lot of these interns or a lot of these people who just came as apprentices have stayed on for a long time and have gone on to now do their own projects, of course, with the shared experience. So it is a community being developed where we are not trying to hold on to any of these techniques or technologies which are not ours to begin with in any way. And it is free and open to share and learn. Anyone can be a part of it if their intent is to take it forward and not to damage the idea of this open sharing. Coming to the idea of an intern or an apprentice, yes, we have, of course, most of our people working as interns, and they're always on site, and we are looking at methods to very quickly build buildings, where we really look at an architect's development or an intern's development through their ability to connect with these materials and with these techniques. And these are some interesting kind of projects which we've probably won a few national or international awards. So I just like to wrap up saying that the whole question of architectural education and the way you pursue your learning process comes down to some very relevant basic fundamental questions as to are you going to be walking in a straight line where you do not know of a future? Or are you going back to the center of the circle where people, animals have already established certain philosophies, and pursuing that will definitely take you to a safer place in this world. All right, I would thank you and end this seminar.
Thank you so much, Architect Gautam. The questions you had were certainly thought-provoking, and it was pretty fascinating to see how technology has existed through nature and human history, especially with the use of vernacular materials. I'm extremely delighted to have Dr. Amardeep Dugar yet again at VSpark. Dr. Dugar is a trained architect and an advocate of all the elements of lighting, design, education, and research. He is the founding principal of Lighting Research and Design. He has a master's degree in architectural lighting from University of Wismar, Germany, after which he went on to do a PhD from Victoria University of Wellington, New Zealand. He has several accolades and recognitions to his professional work. He has also been a sought-after expert by architecture schools for lighting design lectures and workshops. I invite Dr. Amardeep Dugar to please share his thoughts.
Thank you. Hope you're able to hear me and see my screen?
Yeah, we are able to see.
Okay, thank you. So when I was invited to talk about this seminar, I was just looking at this whole theme where I think there were talks about digital technology, future, sustainability, and lighting. So I kind of clubbed all of these information into one and try to see what the future of lighting design per se would be. Lighting, I mean, I'm an architect, my first degree is architecture, then I specialized into lighting, and I've been working in the field of lighting design ever since. And it's just a specialization where you integrate lighting and architecture. So looking at what sustainable lighting, sustainable design, initially was where you had a merger between ecology, economy, and equity. So this was the original concept of sustainable design. It still is, and it always will be. But ever since, there have been a lot of paradigm shifts where whole aspect of sustainability is to look into a different aspect. And one concept that I came up with a couple of years ago is something called slow design, where ecology and it's mixed with this whole concept of an entity, where entity could be the individuals, it could be a community. And the whole idea is to then mix ecology entity with an urbanity meaning where you have cultural and socio-cultural aspects. So sustainability is not just about energy savings or savings in economy, but there's a whole concept of giving an individual needs, looking at individual needs of people, of environments, of the community, and looking at a whole cultural aspect of whole bringing all of these together. And how does this reflect into the future of what lighting could be, and architecture and lighting when they merge into one? What could the future look like? I came up with this really interesting article called Welcome to the Luminous 20s, where it mentioned that the first thing would be architecture and lighting. There will not be any light fixtures because the architecture will become into something called a luminous surface. So light and material will merge, and the built environment itself will start creating this continuation fluid visual environmental spaces. So as you enter into a space, you will not see light fixtures, but the ceiling itself will be an illuminated ceiling. The ceiling could be a projection of what is happening environmentally. And the whole concept of light fixture and material would become into one, because the architecture itself will become a glowing space. So you could have glowing walls, you could have glowing ceilings, glowing flow patterns. So the idea is it becomes a healthy lit environment because users receive this maximum psychophysiological response from the building itself. So based on users' moods, the actual space would start looking and becoming a living entity. The second concept is this, as we saw this amazing keynote lecture of virtual world, there'll be a merger between the real world and the virtual world, because architecture will increasingly start becoming media driven and data driven. So by media driven architecture or lighting would mean that this is a concept of this is an actual project of a cafeteria in Germany, which was inside a basement. So since this was a basement cafeteria, it did not have any views to the outside. So the lighting designer and the architect together created this window-like space, and the lighting, the color temperature, and the illumination quality changes as per the actual environmental quality. And this photograph of the image is actually the lake outside this cafeteria. So although the whole building and people are cut away from this whole environmental feel of the outside, architecture itself starts giving this luminous experience. So people who are sitting in a basement still have a view of, or an artificial or a virtual view of what is happening on the outside. And this becomes data driven in the sense that it is environmentally optimized based on what the external conditions are. There are sensors that connect it to the lighting. So based on what if it's an overcast sky, the light becomes an overcast light inside. If it's a sunny sky outside, the light inside becomes a sunny sky. So there's a direct connection between the real world and the virtual world using the architecture. So architecture becomes a portal to the real world and the virtual world. Architecture would increasingly start becoming an interactive space, and lighting would become a prominent part of this. Interactive lighting doesn't mean just by interacting with a smartphone or just a remote control. Interaction would be through touch, through proximity, and through other embodied activities. So imagine a person walks into a space and the person's body language says the person is in a very tensed or a very angry mood, the architecture would start interacting with the person and create this light and relaxing lighting atmosphere. So then the person who's entered into the space starts relaxing just because the lighting is responding to it. Now, this image on the right that you see here is a blow installation. This is an actual installation where people could actually blow into this sensor here. And based on the power of the breath, the installation reacts to the person's intensity. And this is how lighting would start becoming, this is just a start of something which the future of lighting could be, where interaction would be very embodied activities based on person's physical movements, facial expressions, the amount of breathing that the person does, and the lighting would help the person relax with this kind of an interactive lighting spaces. Talking about digitalization of architecture, what would be great is this concept of digital twin commissioning. Now, BIM models are becoming the need of the hour now. Even before the actual building is built, we have some photorealistic BIM models where the designer, the client, the end user can actually see what the actual space would be. So now just imagine if this cloud connected BIM model is connected to the lighting hardware at site. So the lighting designer can be stationed in UK or anywhere outside, and the project could be happening maybe in India. And with this cloud connected BIM model, the lighting designer could actually control the lighting and give this real kind of a lit scenario inside a space based on the user's need. And BIM would become a live simulation. And what this would do in terms of sustainability is that it starts reducing this on-site commissioning costs and traveling. So instead of a lighting designer traveling every time from a different country to the site and trying to commission the lighting, with these cloud-connected digital twin commissioning and BIM models, live simulation and virtual lighting, one could actually control the lighting and just give a photorealistic atmosphere. And this is a really look at using technology for very sustainable solutions in the future. Circular economy is something which is really catching up. Now, it's cradle to grave is what we've been used to, where we have a product or a light fixture. It has a time cycle. At the end of the time cycle, it ends up into a landfill and it's dumped. But with the circular economy, the concept becomes cradle to cradle. So product design would increasingly start becoming a common sense product design. Because if you look at it, if a light fixture or anything has gone bust, what it needs to be done is enabling the repair of the light fixture. And if it cannot be repaired, trying to use the components so that you can use it, reuse it into a durable light fixture. And circular economy would also mean smart maintenance programs. Smart maintenance programs means that the manufacturer or the supplier who's supplied the light fixture for a project will be through, we have seen concepts of Internet of Things. Through remote monitoring, the manufacturer supplier will be able to monitor and broadcast the lighting system's performance, and the supplier would actually know which light fixture is performing well, which is not, which needs a little bit of a repair or a reuse or a complete replacement based on these smart maintenance programs. And the use of bio-friendly materials. The idea is to reduce the embodied energy of the light fixture, toxicity by using more biodegradable and bio-reusable materials. And in the end, you also end up reducing the costs. So landfill is taken to the sides. It becomes a very circular economy of cradle to cradle. And finally, the use of DC power. Now, DC versus AC, direct current versus alternating current, has been a major war which happened several years ago, and alternating current won that war several years ago, and that's why we have alternating current grids everywhere. But now with the use of LED lighting that is coming up, DC power is coming back into place again, because just imagine all your light fixtures that are being used are direct current. So you have alternating current that is supplied. That alternating current is converted using a transformer to direct current, and then it's applied to LED light fixtures. That itself is a lot of wastage of energy. So we have net zero built environments where we have nano grids. So each and every house has its own renewable, recyclable lighting energy systems. Either it could be for solar photovoltaics, or it could be wind energy, and each residence produces its own electricity, and all the lighting and all the air conditioning and all the ventilation, everything is supplied locally by the residence nanogrid. And that is something which will be a DC power nanogrid, where everything is run entirely on internal flows of direct current. So direct current would be the next big thing which would come into the future of sustainable design. Now, those were theoretical concepts. It's always important to support these concepts with an actual real life case study. And this is one very interesting case study that I came up. It's a petrol station in Spain. It's a city called Adanero in Spain. And Cepsa is a flag station. Cepsa is the brand. And the goal while designing this petrol station was that of simplicity, elegance, sustainability, and a very future focus. So the concept is a very simple concept where you have the solid box of where the retail happens, and it has a void of this light and semi-transparent canopy of balloons. So right from the material use, it has been a very future-focused thing. So the whole concept of merging light and material is taken to a next level, because the material that is used is called ethylene terafluoroethylene. It's a very close to an acrylic or a plastic material. So during the day, it's transparent. So during the day, you don't have any use of electric lights, because daylight filters through and you have these beautiful views of the sky. At night, when light is shot through, it becomes an opaque material. So the idea of making this opaque is that there is no light pollution. We've heard about noise pollution, and light pollution is becoming a very critical thing, because light, when it passes into the sky, it causes disturbance to the night life. It also blocks the views of the night sky, because we are all starving for darkness here. We're not able to see the night sky because there's so much of light spill that is happening into the sky. So this becomes an opaque material. So during the day, the whole petrol station is an open area that has a lot of natural light. And at night, it acquires this solid appearance when the light is shot through that. And if you see the light fixtures, there are two types of light fixtures. So there is this LED light fixtures, white color, and the light is only focused downwards. So this white light allows for the functionality. It reduces eye strains with the general lighting. And then you have this red light, which is the corporate color. It is used for color branding. So you see these LED lights that are on top here, they only light up the balloons, and the balloon becomes opaque. So it only illuminates the canopy, but there's no light spill that goes outside. So it's an elegantly integrated system where luminaires are very seamlessly integrated with the overall architecture. And it's an interactive space, because whenever there are no cars in this petrol station, the light automatically dims down because there are motion sensors placed all around. And whenever there's a car that is approaching, the station where the car is approaching, only that illuminates and becomes brighter. So it reduces energy, and it's a very interactive space, because based on the amount of users, the amount of cars that are coming in, it becomes an interactive space. And if you look at the right-hand side of this, you see those windmills that are there. So these are actually windmills that are custom designed for this petrol station. So this petrol station has its own power generating unit of renewable energy. So it's not able to provide the entire energy requirements for this petrol station, but the wind power is sufficient for the lighting requirements of this petrol station. So renewable energy is taken in this station too. So, and I think it's not a rocket science, a very simple design that is being implemented, and I'm sure it can be implemented in a lot of areas, in a lot of other design studies. So summarizing, what would be the evolutionary way forward? First is the designer's transformation. Designers can be architects, designers can be interior designers, lighting designers, product designers. They need to transform from spatial designers to experiential designers. What does this require? First is scripting. Now, user experience is the next definition of architecture, because users are always looking for better experiences. So their experiences have to be clearly scripted, like a movie script or a theater script. So scripting, storyboarding. So you have architects create a clear storyboard of how the user what are the different kinds of users in a space, how those users will be using that space in terms of their activities, and finally simulating. So we've talked about BIM and these amazing simulations which we saw in the earlier presentations. So each of these users is mapped and it's simulated so that designers are able to identify the loopholes in the design even before the actual design is built. So this is where the designer's transformation comes in. There is also an obligation. Designers need to feel obligated towards the bright and a right future. First is thinking. Thinking is to start looking at regenerative natural systems and then looking at mapping. So we talked about this concept of cradle to cradle. So users, the designers have actually start mapping the life cycle of each product that is being used in a design. From my perspective, it is the light fixture. Right from the time the light fixture is manufactured in the factory, what kind of LEDs are being used, what kind of housing is being used, to what happens when the light fixture is supplied, what's this life cycle cost, and after the light fixture runs this life cycle, what happens to the light fixture? Does it go back to the manufacturer? What happens? So that mapping has to be done. And then specifying what is needed for the actual design. So the obligation would mean thinking, mapping, and specifying. So summarizing my presentation, sustainable initiatives need to have a very broader context where you need to start going beyond the quantifiable measures of energy and money. So the quality of the environment has to be enhanced so that what the individual entity and cultures and social cultural urbanities would start experiencing. So the first factor is ecology, ensure that lighting does not disturb the ecosystem. The second factor is entity, you ensure that lighting provides deep satisfaction to individual psychophysiological needs. And urbanity, where you ensure that lighting provides deep satisfaction to the community's socio-cultural needs. That was a very short presentation. Thank you very much.
Thank you so much, Dr. Dugar. It was wonderful to see how lighting technology can intervene in the ambience of a space, and also how the sensory responses can take lighting to a whole other level, reduce waste, and also make the entire system sustainable. It was a wonderful presentation. Thank you.
Thank you.
Next, we have Dr. John Stinson. Dr. John completed a PhD with the focus on architectural technology, building performance physics, and behavior change related to smart homes. Until last year, John worked as a research fellow and principal investigator for construction industry-led R&D projects, focusing on energy efficiency retrofit, building surveying, sustainable architecture, and human factors. He founded Building Research Solutions, which strives to bring sustainability R&D closer to construction and architectural technology. He is presently the chair for the CIIT Scotland East region. Very happy to welcome Dr. John. You may please begin, sir.
Thank you very much for the kind introductions. So I am going to share my screen and you can give me a nod if it's sharing okay. Right, that should be it shared. And it should be loading just now. So hopefully you can all see that. If not, you can let me know.
Yeah.
Right.
Visible.
Superb. Great. Right. So good morning or afternoon or evening to wherever you are joining us from around the world. It's amazing to see so many familiar names from the UK and Ireland. Now, I'm going to be trying to move through this presentation quite quickly, which will hopefully save some time. So I'm honoured to be joining you all today amongst a really great star lineup of speakers. And on behalf of architectural technologists in the East, in the Scotland East region, our sincere thanks to all the organisers, dignitaries, keynote speakers and moderators for creating such a unique event. And our thoughts and prayers are with everyone out there who are currently suffering right now. Right, so my presentation will actually tie in quite nicely to most of the topics that have already been covered this morning or this afternoon or this evening. And like some of the other speakers today, I want to present on a thought experiment, which starts with this title, which is a modernization on a classic and very well-known architectural quote, "A house is a computer for living in." So before we go any further, I want to set the scene, and I'll do that from a Scottish perspective through the lens of environment and ecology, and specifically to building performance evaluation technology and also to smart homes technology. Then I'll contextualize all of that with examples from over a decade of my own work in the industry and research for architectural technology practice. And my final thoughts will speak about the merger of building performance evaluation technology with smart homes technology to enhance architecture features. So I'm going to use the word sustainability a lot in this presentation, in the understanding that the word sustainability is a combination of the word environment and the word ecology, but it's also a measure over time. So for sustainability in Scotland, we have many low and zero carbon design methodologies like BREEAM, Passive House, LEED, etc., which everyone here will be familiar with. But in the UK and Scotland, we also have some of our own government-driven sustainability design standards, most of which unfortunately fail after a few years. Now, some of these design standards fail because of their incompatibility with mass house building. Now, Section 7 of the Scottish Building Standards, named sustainability, has been going for about 13 years, and it's a standard that speaks to environment, ecology, design for deconstruction, health and well-being, design for the future, retrofit, and also operational energy and carbon and fuel poverty. Now, the reason why we like the approach of Section 7 is that other sustainability design methodologies would have every building in Scotland looking like this one here, and only because a dark colored cube is theoretically the perfect form for a thermal envelope. Now, the first question in this thought experiment: should we allow architectural flair and imagination to be sacrificed at the altar of zero carbon and sustainability? Or should we support sustainability design methodologies that augment a country's supply chain, insurances, and contract culture? And if we do that, could we effect a greater uptake and deeper reach within even the most cost-effective mass house building communities? Now, within all sustainability standards, we see a fundamental shift from architectural-led solutions to technology-led solutions, because technology in the form of methods of construction and energy systems play a significant role towards a low carbon future, definitely for mass house building. Now, within these standards, building performance evaluation technology is aimed at energy, sustainability, environment, ecology, and takes the form of U-value measurements, infrared thermography, energy monitoring, air tightness testing, indoor air quality, etc. And these are conducted by scientists like me, but they're only ever conducted at one point in time, and that's usually before anyone moves into the building. Then there are smart home technologies, but these are marketed as after-sales consumer products, but they play a fundamental part in lowering the building's heating and lighting demand, which are two energy demands that are regulated by almost every building standard in the world. Now, the next question is, should smart home technologies be part of an architectural designer's toolkit and consequently added to sustainability standards? So, time now for some real-world examples for this thought experiment. So I want to quickly explore two of our past architectural technology projects, which we will call Project 1 and Project 2. So first example, Project 1, comes from a housing innovation project where we provided architectural technology, building performance evaluation, and human factors research services. And importantly here, there were no smart home technologies used anywhere in this project. Now, we, with 35 other partners, designed and built 27 homes using 10 alternative methods of construction. Now, whilst the MOC were very unique and exploratory, every home was heated by very common systems like natural gas boilers, and the sustainability innovation technology was quite low. It was simply PV panels with some mechanical ventilation. And all the other building fabric variables were broadly the same, or at least they weren't statistically significant enough to cause any difference in the results. So on paper, and ignoring the innovative MOCs, these looked like, and they still do look and behave like, normal Scottish homes. Now, with respect to technology, architecture, and sustainability, we learned a lot from Project One. The performance gap between the amount of calculated energy at design stage and the amount of energy consumed by the occupants, whilst it wasn't perfect, it also wasn't horrible. And most of it we could relate back statistically to human behavior. Now, Section 7 was developed during the 6 years between the end of Project One and the start of Project Two. And human behavior elements are included within that standard called the Quick Start Guide. Now, being architectural technology scientists, we had a new hypothesis to test. Namely, if we designed homes to the best level in Section 7, would we eliminate the performance gap? So we had a plan, and like all plans, it was a great plan, where we set out to harmonize the transfer of knowledge between everyone that was involved in any part of these homes. And Project 2 gave us the opportunity to test that plan. And this example comes from a different housing project, but we had the exact same involvement as architectural technologists and building performance evaluators. And again, no smart home technology used in this project. So this project only had one method of construction, which was a volumetric pod. But the sustainability technologies in Project 2 were significantly more intense than those systems used in Project 1. So for example, the very common natural gas boiler was replaced by an exhaust air source heat pump with electric heaters as backups, with MVHR linked to water heating and some PV panels. But all 47 homes were essentially the same in the same technologies and building fabric. Now, we used our building performance technologies after these homes were completed, and they all performed pretty well as was designed. There was nothing weird or unusual happening here. And before the occupants moved in, we jumped into action. So I wrote the script, the client organized the actors, and we hired a professional film production company. And this was the first adaptation of the Quick Start Guide for screen for the building occupants and users. And we did a film version of this because it was deemed easier for everyone to absorb and breaking down language barriers, subtitling and dubs and things like that. So during this video, we were very thorough. We were very, very thorough in what we covered and what we told the occupants they should be aware of. So I'm very close to finishing this presentation. So I want to give an excerpt of what we delivered. So this video is about 50 seconds long, and it's only going to be a little bit of narrative in terms of what the building occupants would have seen when they moved into their homes. So I'm going to play this video and be quiet for about 50 seconds. That didn't work. I'm going to try that again.
Welcome to the Quick Start video guide for your new home. This video contains information on the technology you'll find in your home and the best way to interact with it. This video will give you a brief overview of your home's energy saving features, ventilation system, hot water system, and heating system. Your new home has been designed to be more energy efficient. We selected the technology in your home based on performance and ability. In your kitchen or living room, you will find an energy monitor. This monitor will tell you how much energy your home is using. Your energy monitor should show you your energy consumption and how much money you're spending on electricity.
So I know my colleague who previously spoke about energy displays will be ripping his hair out looking at this display, which we can speak about a bit later if we need to. But for this project, the scene was set and we were ready to be hailed as heroes for solving the human factor element of the performance gap, which has been plaguing architectural technologies for quite some time. It didn't work. In fact, the performance gap was worse in Project 2 than it was in Project 1. Some homes in Project 2 were using 7 to 10 times more energy than was estimated. And after months of working with the clients, construction partners, and occupants, we discovered that the homes were just too complicated. There were too many technologies, there was too many controls, there was too many interfaces, there was too many decision points, and it was too much effort for anyone to engage with to simply maintain their hygrothermal level of comfort. Now, all of these technologies were so integrated within the building that no length of user manual, no length of user video, no length of interaction with the occupants could solve this particular issue. But it also made no sense to us as scientists. How could these buildings be performing so badly? And then we found the missing link because it was something we never looked for in any of the previous projects. There is a curve, and this curve is beginning to describe the impact of an occupant's prior experience with sustainability technologies from their old home before they move into their new home. So the question now is, as all homes are becoming more technology heavy, will the occupants eventually learn to use every type of control for every type of new domestic building? So will this curve solve itself? And if so, how long will that take? Or should we accept that energy systems for homes will always be more complex because they need to be more energy efficient? And should we accept that the sustainable home is now behaving more like a non-domestic building? So this is my final slide. And what I want to say is building performance technology takes a lot of measurements about a building's effect on the environment and the ecology, but it only does that often at one point in time. Smart home technology takes lots of measurements through a building's life, but then it throws this information at the user. Sometimes it can be hundreds of messages and dials and numbers and gizmos and widgets and alerts. And it requires the user to understand what that alert means, put together an action strategy, implement that action strategy, deliver the changes, and then wait for the next alert to come back if something actually works. That's a very convoluted pathway, including very defective human beings, which we are as decision makers. But if we are to design smart home technology to capture information that is normally captured by building performance technology and then is connected to outputs to control our environment, then we could have technologies for architecture futures. So I want to give just a few examples before I wrap up here. Something that goes beyond the novel smart thermostat and the novel in-home display. Can we embed thermocouples into junctions and corners to calculate real-time temperature factors and connect that to ventilation systems to regulate the accumulation of condensation? I think so. Can we embed heat flux sensors into walls, floors, and roofs to predict the times for energy efficiency retrofit? Yes, we can. Can we add pulse sonic air tightness units and solar irradiation sensors to be linked to window controls, dehumidification, and air condition units? Yes, we can also do that. And can we use the same sensors to be linked to UV LED lights woven into fabrics, woven into furniture, into rugs, into pillows to emit natural, healthy light whenever normal natural light is unavailable? Well, with low power community Wi-Fi meshes connected with central servers for a housing development or a village, plus slimline sensors, then we can embed all of this within the thermal envelope of our homes, and this can be done relatively easily at scale. So my final point is there is a very big value proposition here. For one, the house building community would learn from real-time in situ data about their products and about their users' behavior. And they could move away from the archaic industry benchmarks for energy efficiency of our homes. For housing cooperatives, for housing users, for housing associations, for landlords and for local authority housing, they would inherit technology that could provide proactive scheduling to enhance retrofit maintenance. And there's even easy wins here for the healthcare system. It could be a step in the right direction to collect data for healthcare professionals to better understand and address issues like sick building syndrome and people who are discharged from hospital and recovering in homes. And finally, I want to go back to the title of this thought experiment with a small amendment. Should we be designing our homes to be self-regulating environments for low energy, uncomplicated, comfortable human habitation? So thank you for your time. I've been Dr. John Stinson, and I hope you've all learned something here today. So back over to the moderator.
Thank you, Dr. John. It was indeed quite intriguing to think how human behavior can be a vital part in bringing sustainability into our own living spaces. I'm pleased to welcome Dr. Karam Al-Abaidi for the next presentation. Dr. Karam is a senior lecturer in sustainable architecture and a course leader for MSc Technical Architecture at Sheffield Hallam University. Dr. Karam is an architectural engineer, educator, and international researcher in sustainable design and environmental architecture. His research interests include environmental and biomimetic architecture, building performance, building simulation, energy efficiency, indoor environmental quality, and smart buildings. You may please begin, sir.
Thank you so much. Good afternoon and good evening, everyone. Thank you so much, actually, for this invitation. I'm really glad to be actually with you today. It's the kind of opportunity actually to share with you our, I can call it teaching approaches and methods at Sheffield Hallam University. So I'm going to share my screen now, and just please give me a note if you could see the screen. Is it okay? Okay, thank you. Thank you so much. Just going to put it on full screen. The title actually of my presentation is about environmental design and building performance in architectural education at Sheffield Hallam University. The approach maybe is quite a little bit different from my other presenters, but is actually adding up to all the information that's been presented before. Also, the link or the aim that I want also to present in this slides is to provide an overview from the I can call it education from the university, and also how we can connect the information and the learning process with the industry. So that's a kind of like a link actually I wanted to present and share with you in these slides. So maybe I could just give a very kind of like a clear direction to the slides or what I'm going to present. So at the first, I'm going to give a very clear ideas to our objectives and our, I can call it goals of teaching environmental design and building performance at Sheffield Hallam University. Then after that, I'm going to show you our sustainable model of how we provide this kind of learning process supported by digital technology. So all the information here, so the things is going to be actually reflect on our philosophy, how we link or how we develop the understanding of environmental design and building performance for our students through all using the digital technology. So after that, I'm going to show you also and present some kind of like a type of partners or tools, digital tools that we're working with. And finally, I want to kind of like explain or not explain, just to support, I can call it here, the aspects of the sustainable aspects of our model and how the student, they could really manage to produce a very successful, outcomes from our teaching approaches and methods. So in general, our goal is to advance our students with a high level of environmental and technical knowledge through different stages of different levels through their actually education journey. We created or we've developed kind of like a sustainable model of learning process supported especially by the digital tools. So we go through this kind of like different stages through different years from like year 1, year 2, year 3. And mostly here, actually, my presentation is about the undergraduates. So I wanted to share with you how we can take this kind of a journey from using a physical environment and move towards more digital, I can call it virtual environments, and how can connect that kind of like a digital aspects within the learning process and even with the philosophy. So the way that and the approach that we are dealing at Shafi Hallam University, we try to enrich our students to be able to demonstrate the knowledge of environmental design strategies, laws of physics, building services. So at the early stages of the learning process with our students, we try to engage them with that kind of like different case studies or different kind of call it strategies and tools that could be suitable to enhance and advance their knowledge and understanding about environmental and building performance. Then we work with them to develop their understanding about provide a proper integration between the passive systems and active systems. Then we slightly move from the kind of call it qualitative approach and more design approach to more related to quantitative approach, where we work with the student to model, test, and analyze specific environments within their design studio, with their design projects. Then we move to like another level. That's a kind of like an approaches to after identifying examining certain environments, how the student could improve this kind of like certain spaces and environments with the suitable solutions or suitable technologies. Then we move towards the ends where we actually approaching something we call the optimization and help a student to optimize the design through understanding the best building performance or the suitable actually environment for their occupants or for the users to achieve the higher satisfaction. So there's a kind of like a journey, I can call it. We are moving from a kind of like a physical environment towards more about digital environments. And to jump directly what I can call it to a digital environment or utilizing a digital technology is not quite easy, in the education. So we need to take this kind of like a journey of movement from the early stages and how we can connect them to move towards actually to the higher level and to engage with, can call it the virtual environments. These kind of like aspects of strategy is quite important to improve and enrich their employability skills. So it's very critical and very crucial to go and engage actually with these kind of things. That could cover the both. We are dealing with architecture students and also with architecture technology students at Shafi Hallam. So moving to our, can call it the process and how we move and teach the students these kind of aspects through like a kind of 3 different years at the undergraduate studies. We are dealing or working with a module called Environment and Technology. It's a kind of a standalone module, but at the same time, it supports the design studio projects. So we help the students to engage, and understand the digital tools by looking at different, I can call it methods or different simulation tools. So at the first year, we just provide them with the information related to building fabric, principle of environmental design, So the specific methods, we're working with them through the research, calculation, drawing. So we try to enhance and we try to advance the students, especially at the early years, to understand this kind of like aspect related to building physics, related to engineering, related to the environmental and sustainability areas. Then we move to second year. We encourage the student, we advance the student also to understand more the aspects related to the passive design strategies and the technological integration in buildings. So how they could work with the different passive strategies and active systems also at the same time. The quantitative method, or the way that I can call it, we approach. We continue encouraging our students to utilize research. So they continue using all the research tools and aspects. Besides this one, we open for them the opportunity to design and model. So that's can call it the first stage now, where we can connect the student to move from the physical environment where they work at the lab, where they understand actually the reality, and slowly to move to the digital environment by testing, by looking at the models, how they could actually model their design and their environment, utilizing again the digital technology and specific softwares such as different BIM platforms, environmental softwares. So the student will have this kind of capability to understand and comprehend the approach. Then we move towards the third year. The student will have this kind of like an advanced environmental understanding. They will be able to enter, I can call it, the field of building performance, where all the things that have been covered during year one and year two, they're moving actually to the final year. They will know more about how to assess the environmental conditions related, for example, to a thermal condition inside the building, ventilation, solar aspects, to understand even the impact of the solar outside the building. For example, assessing even the levels of solar panels or renewable energy. And all these kind of things will help him towards the end to produce, auto-generate an optimum or sustainable, I can call it, construction technology that will be helpful and also at the same time will engage with the industry. Within this kind of like I can call it sustainable model, our students, especially during second year and third year, they will be in touch with the industry. So my colleagues and all the staff actually at Shafi Hanam, we work closely with the industry to enhance the experience of our students and also at the same time to get a feedback or receive a feedback from the industry about the needs and the requirements of that kind of like a learning process. So there's always the kind of like a continuous, I can call it discussion and communications between the education and between the industry, and especially to enrich and enhance our students at architecture technology. So that's kind of like an aspect. I just wanted to show how we moved from the objectives and the goal and presenting the sustainable model. Our partners and the digital tools that we utilize at Shafi Hanam, mainly we have two partners. I'm only mentioning here, I'm talking about the aspects related to environmental design and building performance. We have different modules. We have different actually aspects and areas. So in the aspects related to the environmental design and building performance, we are working closely with our partner in Autodesk, especially by helping and supporting the students to know more about the BIM, and also the specific plugins that provided or supported by Revit, the BIM, looking at the insights, the building performance energies, Enscape, LM Tools, and Sephira, and all these kind of things really provide a very clear understanding for the students, especially I can call it at the second year, where they are through their in the middle of their learning journey, where they understand and try to relate the aspects of engineering, the aspects related of building physics within the kind of call it the digital technology. Then we move towards the final year when we prepare the student to be ready to be outside after the graduation. Some of our architecture students also during the second year, they are actually taking placements outside, so they practice outside. They bring all their knowledge and understanding. They gain it through their, through their training. They return back to the final year, and there where we introduce to the students our final steps and our very clear, level of building performance. So we have this kind of journey. We started first with the environmental design, with sustainability at the early stage of their learning process. when they move to the second year, we try to, I can call it, build up their knowledge with the different software and modeling tools. And then when they move to the final year, when they are ready to develop their final projects, they will working with a very professional, I can call it, type of softwares or even tools to develop their understanding. And the mainly and the most importantly is to support their studio projects. So there's a kind of like a continuous discussion and collaboration and working between, I can call it, the environmentalist and the designer and the architects and the architectural technologists at Sheffield Hallam. When we move towards the final year, we're working with other type of a software. It's called the IS, Integrated Environmental Solution. This type of a software support our students to know more about the aspects related to solar analysis, energy, thermal, ventilation utilizing CFD, computational fluid dynamics, and also related to aspects related to, I mean, the cost and the comfort inside the building. So all these kind of things support the students, develop their understanding, and there's, as I mentioned, a continuous discussion between different type of modules. My colleagues working on the different, modules also, they implement or develop the same approach with different universities. So there's a kind of like utilizing the digital, technology and tool as a platform to help engage, with the different industries or even with the different partners. So this is kind of like an approach, I can call it, in a way of developing our sustainable model of teaching and approaches at Sheffield Hallam. Now I wanted to share after this one is the outcomes, how this kind of sustainable model of teaching at Sheffield Hallam is actually demonstrated or presented through the students' work, or that I can call through the student achievements. And some of the examples I'm going to show them also later is only related to this year and the last year, which is represent, we can call it, a successful approach of the sustainable model to overcome the difficulties, which is currently the issue that we have with the Corona situation, and with the remote learning and with the online learning. So by utilizing the digital tool, or I can call digital technology, it's really enhanced the student learning and really actually supported their understanding about, architectural technology in general. So the way that we approach, I just wanted actually to demonstrate about the outcomes from this kind of teaching model.
Dr. Hallam, Karan, sorry, we are sort of going beyond time here. I would just like to hint you here.
Okay. So I'm going to just do quickly, possible.
Yeah, sure. Okay. Just you can take about a minute.
Okay, about a minute. So I just wanted actually to demonstrate the outcomes that the student they presented. Oh, sorry. Yeah. So you can see the outcomes. They started by understanding the different places around, in the UK or even in the Europe. Then they reflect this kind of understanding with their design project or design studio. And we help the student during this time or this stage to engage with different type of modeling systems or modeling softwares to develop their design model. Then we move towards more in-depth understanding and utilizing these tools by looking at solar analysis, understanding the indoor condition. So we look with the student and we develop the student their indoor environmental condition, operative temperature during different seasons in winter and in summertime, how they could actually optimize and how they enhance the situation or the design of their model. Also, we work with them to demonstrate their capability and their understanding about ventilation by utilizing CFD, the computational fluid dynamics inside their building. We're looking at the specific actually model and spaces. We're working also with them by developing their understanding about daylighting and the lighting levels inside. So the specific type of the glazing material, the size of the windows, and the technical aspects of the requirement that could be provided outside from the industry, how they could bring it inside their design and test it to find is it suitable or not suitable. All these kind of things will end up at the end to produce a very sustainable, I can call it, construction technique and technology to support their learning process and also to inform, their design in general. So it's a kind of like a journey. We work from the beginning with the physical, I can call it, environment, at the end towards the digital environment they learn different type of aspects and details. And when they reach to the final stage, they are ready actually to reflect all their understanding about simulation, about digital aspects, and they are presented in an architectural form or architectural way that to inform their design and actually to give them a very clear and complete picture to support their work and their employability skills later, after the graduation. So thank you so much. I'm sorry, actually, I over the time with the presentation. Thanks a lot.
Thank you, Dr. Karam. It is certainly essential to bring environmental consciousness in the studio pedagogy. It was really interesting to see you demonstrate how you have incorporated various levels of environmental design in the subsequent design studios. It was a wonderful presentation. The final presentation for today is by Ms. Sophia Key. Sophia is a chartered architectural technologist. She graduated from Derby University, UK, and has a post-graduation degree in energy and sustainable building design from Leicester de Montfort. She has experience working on mixed-use retail developments in China, Vietnam, and Malaysia. Sophia has the credit of delivering Changi Airport Terminal 4, a fully integrated BIM-designed airport project with stringent green and environmental design aspirations. She is presently working for Arcadis as a principal sustainability consultant, integrating sustainability on a wide range of projects from master planning to hospitality. Sophia is working closely with CIAT globally in delivering the message of architectural technology, sustainable design, and engineering in global working practices. Sophia, you may please begin.
Oh, thank you so much for the wonderful introduction there. Some fantastic presentations today. The previous presentation, the students will surely be ready for industry, and it's lovely to see that kind of preparation story. So I'm Sophia. I'm a chartered architectural technologist. I also have an MSc in energy and sustainable building design. So I have a crossover between the architectural and engineering sectors. Since graduating in the UK, I've worked in Hong Kong and China and Singapore, and now on to Dubai in the Middle East. So I've had the opportunity to work across some fantastic projects globally, including Singapore Changi Terminal 4 and some projects in the UK and here in the Middle East. Now, the reason that I bring up this kind of global outreach in terms of my career is actually how I use digital technology to work for me. So how to be adaptable in the industry and how to work as a sustainability consultant in many different regions. And digital technology is kind of the key point and the pivotal tool that I use to be able to be a sustainability consultant over a wide range of projects globally. So using desktop assessments, we look at environmental conditions across multiple project locations. So I could be sat here in Dubai and working on a project in Saudi Arabia or a project in Singapore. So digital technology allows me to assess the sustainability criteria, to assess environmental conditions and really capitalize on those natural environments, no matter where the projects are. So we're moving very, very, swiftly away from the typical environmental information that we get. We used to get when I was studying, which is, a typical sun path and a typical rainfall chart, for example. I use a combination of tools, mainly the Rhino Grasshopper plugin, Ladybug. This allows us to run off those initial wind and rain and sun path studies. And we look at various things in terms of solar radiation, temperature, humidity. We look at a combination of those environmental factors such as temperature, humidity, and wind speed to have an overall felt temperature understanding. So you could be in a 28 degrees environment, but if the humidity is up at 80%, that makes you feel a lot warmer than an environment where the humidity is lower. So we use that combination of environmental information to integrate into one informed, study as to how the environment is in that location. We also use Ladybug for shade benefit analysis. So we all know that obviously when we're stood outside, if the sun's out, if you have a shade above you, you feel a lot cooler than if you're in an exposed location. And we actually work hand in hand with the architectural teams, the landscape teams, lighting designers, facade designers use this environmental information to really environmentally design their within their disciplines and their scope of work. We also look at renewable potential. I'm here in the Middle East. We have a lot of natural solar energy. So we study renewables using the same software. And also of key interest for me is outdoor air quality. So this is looking at the air quality externally, especially when we have sandstorms and desert storms here in the Middle East. We need to understand kind of how that's affecting human health. So here, this is an example of some of the diagrams that we get from this software. So you can get the typical diagrams, and we include these within the reports that we produce very early on. But then as we move through the design stages, we integrate the geometry into the software and really begin to understand how the geometry and the studies and the options of massing, etc., really are performing. So once we've run the initial environmental study, we interpret and extract meaningful data. Now, instead of just having a sun path or a wind rose, we would look at what is happening. You know, when are these occurrences of temperatures above 24 degrees occurring here in the Middle East? When are those instances happening? When are those sun vectors for the very high solar radiation happening? And how can that inform solar design, shading design? So we use something called a conditional statement. So this is a screenshot of the script that we use in the software in Ladybug. We will ask the software to show us those moments or those positions of the sun where the temperature is above 24 degrees. Now, why this is important is because we can then design our shading and our outdoor spaces based on the positioning of the sun in the most extreme time of the day. So we would look at this information and design around those weather extremes and also look at the comfortable moments. So we would look at the windrows and say, you know, when is the wind speed above 10 meters per second and above 24 degrees Celsius, and when is it below those instances? So when we're discovering these comfortable winds, we're able to, you know, inform the locations of having openings within the space. We're able to inform locations of outdoor recreational areas. So it really does help us inform the architecture at a very early stage on how the massing and the orientation would work to be optimized. We also interpret the weather data based on the type of building. So for example, if we're doing a school project, we would look at those hours and the weather data for the hours where the school is open. And we would design around those hours so that we could really optimize and enhance that environment during the operating hours of the school. We also go one step further. We look at the building geometry. So once we've done our initial environmental analysis, we would look at optimizing the massing and the orientation of a building. So we're moving away from having environmental treatments, for example, high performance glazing, just on all orientations of a building, and actually informing and engineering the facades so that they react in a responsive way to the environment. We also look at overhangs and optimizing those in terms of shading the outdoor environments, especially in such extreme temperatures. Even here today in Dubai, it's 41 degrees and we're in April. So, you know, for me, something that's very important is to be able to enhance that outdoor environment and moving away from being inside our buildings all the time and actually expanding that amount of time that we can enjoy our outdoor spaces. I think that's a real key part for human comfort. We then work hand in hand with the landscaping team. So based on our studies, we can see that certain areas of the landscaping are getting a lot of hot winds or a lot of direct solar gain. So we would look at landscape treatments, positioning trees, canopies. We would then integrate renewables in the canopies and some of the locations that are getting a really nice amount of daylight with very minimal overshadowing throughout the day. We look at CFD wind studies as well, which informs us as to how the air movement is traveling through the space. particularly when we're doing a large tower building. We don't want to have an uncomfortable environment next to the tower. So we look at all of this very early on in concept and schematic design stages so that we can inform the design process. Another key benefit of using these type of tools, again, we've discussed IESV in the previous presentation. We do energy modeling simulation for a building that would potentially be the worst case scenario. So the most solar exposed building here in the Middle East. So we look at that and we look at a few iterations of the facade U values, glazing values. We look at the HVAC systems, we look at lighting systems, and we inform the most suitable or the most energy efficient design. And we feed that into the architectural team, the facade team, the MEP team, and we work as a collaborator to inform and to really refine the all of the disciplines. So we have to be, you know, a specialist of many trades, being a sustainability consultant. We then also look at the daylight. We look at the glazing values to see how much daylight penetration is getting within a space. We have to balance that very cleverly over here because we have a lot of glare from the sun, but we also want to allow natural daylight to penetrate the space. So we look at multiple options. For example, here we would refer a modular system and try and work out the optimized shading depth and the optimum orientation for an external shading system in order to allow maximum daylight with reduced solar heat gains and reduced glare. So it's quite a balancing act, and using parametric tools actually allows us to fully understand the best option before we even go to site. Here we also study a streetscape, so we would model different orientations of buildings and look at the canyon, the streetscape in between, and advise the master planning team which is the best orientation for the streetscape and if any additional shading treatment would be required down the streetscape to give the maximum comfort levels outdoors. And then we're moving inside the buildings. We use a lot of digital technology. I mean, I think most people can appreciate over here, I think that we spend 90% of our time indoors because of the extreme weather environment that we have here in Dubai in the Middle East. So the systems that we put into the building really do control and have effects on health and well-being. So we look at ventilation systems. We have CO2 sensors positioned in areas that have, you know, unpredictable or multiple people within one space. We encourage demand control ventilation. We also look at localized thermostats. So a typical building would have a thermostat in an area which generally wouldn't be occupied. We would guide the MEP team into putting localized thermostat or sensor controls so that we can, you know, really sense what the person is feeling in that space rather than in a space that is potentially not near where people are sitting. And this works particularly well in home environments when we're looking at housing projects, to have individual sensors in bedrooms that are connected to the master thermostat in the hallway that would then, you know, control the ventilation system. We also, again, look at outdoor air quality monitoring. By having real-time screens within buildings, we can actually inform occupants about the outdoor air quality. So, for example, if we have a sandstorm, it might not necessarily be the best air quality. So we would encourage real-time data sensors and monitors so that people could understand their environment externally. Then for daylight, we look at different lighting configurations within a space. So we understand that the lights that are closest to the windows don't necessarily need to be on throughout the whole of the day. So we encourage installation of LED sensors there in localized locations and have separate controls as we're running through the roof through the space. So the lights on the window side might be off, but the ones within the room further down may be on. We also look at circadian lighting. This is one thing we do with WELL certification. It's quite a key and important lighting design feature when we are spending so much time in artificial or indoor environments. And that is minimizing the effect of electricity light, on human circadian rhythms. So changing the render of the lighting throughout the day based on whether you should be waking up or going to sleep. This also ties in with automatic blinds and curtains. So digital technology can activate your blinds to open when it's time to wake up in the morning so that you're woken up with natural light coming through into your space. We also look at occupancy sensors in terms of energy reduction. So having lights in communal spaces only on or off based on whether there's an occupant within the space. And digital technology really helps us to achieve that, occupant-driven delivery of building services. Another cool thing we look at for smart homes is these remote GPS activated cooling and heating systems. So you effectively have on your smartphone your installed ventilation or aircon system, and it can tell when you're getting home or when you've left home. So your aircon is turned off while you're away, and then as you're approaching your home, your aircon is activated, and you are then entering into a cool environment, which is really, really interesting, because I know often I've left the home before and realized I've left the aircon running or the lights on. So you can activate it all over your phone and control it being away from home, which is quite interesting to see how digital technology is going. So the last slide is the ecology studies that we do as part of our site assessment work. Again, the way that digital technology helps us now is that we can do desktop studies for sites that we are working on that are on the other side of the world. You could be sat in the UK and you could be looking at information for Thailand, and I think that's something that's very interesting. We look at databases and looking at our site information, we can establish whether there's any threatened or endangered species within the site that need to be protected. We can identify the unique habitats or corridors, any significant vegetation or that needs to be preserved. Over here in the Middle East, we're mainly working on sites that have never been touched before. So this information is very important to make sure that we don't disturb any ecology and that we fully understand, any significant assets on the site before we go to site. And then include a mitigation strategy in our landscaping and master planning design to make sure that those are preserved. And again, we can look at environmental studies such as average monthly rainfall, the seasonal temperatures, winds, solar exposure, for example, as well as establishing from our desktop studies if there are any flood hazard areas, or any existing water resources available on a site. So yeah, I think this is the end of my presentation. I tried to rush through it because I know we're quite tight on time. Thank you so much for the opportunity for talking this afternoon. Thanks.
Thank you, Sophia, for that enlightening talk on weather optimization within architectural spaces using digital tools. There's certainly a plethora of benefits one can look for in these tools to bring about an almost completely sustainable build structure. So we have now come to the end of all the presentations. It is now time to go ahead with the panel discussion. It is my privilege to introduce our moderators for the panel discussion today, Professor Sam Olwinkle and architect Deepa Parekh. Professor Sam is the former president of CIAT and chair of CIAT Education Board. Sam's background is in architectural practice, serving as partner and director of Buildings Investigation Centre, Edinburgh, specializing in building design evaluation and technical performance. He also has experience being a member of the Scottish Building Regulations Advisory Committee, expert panel member in fire regulations review, and many more. Presently, he is an emeritus professor of Architectural Technology and Building Performance and Director of Research in Built Environment at Edinburgh Napier University. Very happy to have you here today, Professor Sam. Architect Deepa, welcome to VSpark once again. I'm extremely happy to introduce her to the audience. Deepa has a background in architecture and building science. She has worked on a number of projects in the US and in India with a focus on bridging the gap between architectural design and technology. Her work at EDS includes facilitating green building certifications, high-performance building consulting, whole building energy and daylight simulations, green building policy research, analysis, and communications. Deepa is currently leading initiatives to grow engagements for net zero energy buildings in India under the USAID-funded Market Integration and Transformation for Energy Efficiency Program. A USGBC faculty and ECBC master trainer, Deepa has conducted over 35 training programs for a varied group of learners in the form of online programs and in-person workshops. She is also actively engaged in academics by regularly teaching graduate level courses as well as advising students on their graduate thesis. I now hand over the floor to Professor Sam and Architect Deepa to conduct the panel discussion. Ma'am, you're on mute.
Thanks, Deepika, for the wonderful introduction. And also, thank you for having me a part of this session. While the presentations were going on, Sam and I were just, interacting behind the scenes, and we really enjoyed all the presentations. Each of the presenter had to share something very different. And, I liked how he had a multitude of things from end user engagement to looking at virtual reality and how it could be an experience for designers and users. Also looking at material in a very hands-on way, such that it's literally a departure from technology as we kind of use in the literal sense, or that we know in the literal sense. Also looking at software to inform design and teaching the same to students. Clearly we have access to sophisticated tools and technology for both design and construction, and also, during operations to interact with the end users. That's on one hand. On the other hand, we have organizations and countries even coming up with their net zero commitments by 2030 or 2050 and such timelines. Now we are discussing, all this under the bigger theme of today, which is digital technology for built environment and ecology. And that's where I kind of bringing in these net zero commitment, which is very much, today everyone is talking about it and really serious about it. So that's the second. And on the third aspect, if I look at the built environment immediately around me, then it sort of does not reflect the kind of access to technology we have. We can literally design anything, build anything, but the built environment does not exactly look like the outcome of having access to such technology. So I'd like to first throw this question out there to each panelist and go around the room and have everyone share their perspectives on why do we see this gap? I mean, what are we missing here? And really like your thoughts on this. We could start with Miss Sophia Key. I think she has to leave early, and then after that we can go around the room. So all the presenters can get a chance to express their opinion.
Sorry, thank you. My understanding of the question is, why is there a gap in
the way the buildings are built as on today that we see around us?
Yes.
And the fact that we have access to so many sophisticated tools and we're not able to bring that understanding or the real power of those tools in building the built environment that we wish to see.
Yeah, I think there's sometimes a little bit of a information overload when you're working on a project. you could be receiving so many different pieces of information from many different stakeholders. And it's distributing that information between everyone and fully understanding what it means. For myself, I mean, in sustainable consulting, you have to be, as I said, a jack of all trades. I have to understand what the MEP consultant means when he's talking about, his systems, and I have to understand what a landscape consultant wants to achieve. So it's about having that communication skills. Now, for me, the best way to do that is to have regular coordination, regular check-ins with consultants, even when necessarily they're not scheduled. And that is, just having conversations on a day-to-day basis about how the design is progressing, and, really being able to explain and help everyone understand why we are doing certain things. There's quite a lot of sometimes resistance and sustainability in the industry because we have to go over and above what our typical day-to-day job would be. We have to do more. And, it's the way that you portray and explain and really keep, collaborating with others that really gets the job over the line and really gets you, a very high certified building. And it's not without its challenges, is because there's so many different technologies available, and there's discrepancies with workmanship. So, for example, you could specify a facade that's got a very, very good U value, a very good thermal value, but the people on site that are making the facade could not necessarily have the understanding and the experience with that system. So I think that the gap comes in many, many different stages of projects, from the collaboration stage to the policy writing stage, all the way through to the construction stage. I'm lucky enough to work all the way from concept to delivery. So, I feel that I can push that all the way through. But it's not without its challenges, and it's not without annoying a lot of people when I'm asking them for things, and constantly asking for documentation and specifications, and but it's part of really loving the job, I think, and really being passionate about what you do.
Thank you. I hear you. I have similar experiences in my consulting role as
Yes.
well. So as I understand, it's pretty much a problem of plenty when it comes to tools and communication gap on the ground between different, consultants or specialists. Thanks. Thank you. So I'd like to hear Dr. Mulay Chalal. What do you think, is the gap, and why do we see this gap?
I think Mr. Chalal has left. There's a message in the chat box just a couple of minutes ago.
Okay. Sorry, I didn't see that. Okay, so then we can maybe go around the room. Architect Varun, would you like to share your thoughts?
Yeah, sure, if you can hear me. Well, see, Le Corbusier, I think in 1929 said a house is a machine for living in, or something like that. And, through his life, he himself slowly learned how wrong he was. In the last few buildings that you look at, he built either the Ronchamp or I think the monastery at La Tourette. He really looked at very rudimentary architecture, where architecture is very simple, whether it was the shading devices or the kind of spaces that they were created or the materials he used. It really is like, humans using one single material to create a built environment. There's not too much complexity. They're not systems that you just plug in and you depend on them and you're slave to them. And those systems have to be changed now and then. And it is just this direction that we've taken towards complexity that it is a race, and very few are even interested in that race. People on the ground still want to build very simple buildings. And it is a challenge for sustainability consultants that, of course, building for the top 0.001% of the world is a certain direction. but that is a very limited space, and not everyone can be Sophia Keith. Because it is a very tough job and in a very niche environment. In a country like ours, I chose to come back. I was a BIM consultant. I was doing Sophia's job at Stantec in Canada. And I left that 7 years ago to come down to India and start doing something hands-on, because I really felt the same question that you're asking, that there is such a large gap between what is the ground reality. And we as people who have seen the other side or seen two sides of the coin can surely pick one. Thank you.
Right, thank you. So clearly what I hear is, and it was reflective of the examples that you showed. It's more simplicity, and it's the complexity which makes things difficult, and hence we probably, it's like a repulsive action more than an
And it is not, it's very simple to make things very complex. But it's very complex to make things very simple. And it's not easy.
Completely agreed. In fact, just like how you went back from BIM to doing what you do, I kind of looked at education as the answer to fill that gap, and trying to really, really simplify building physics. It is so complex, but trying to do a little bit on that. So that means, this really ties into what Mr. John Stinson, you showed in your example, where you gave in your experiment access to technology to the end users, and it was so complex perhaps that instead of energy savings, it actually resulted in increase in energy use in the houses. So I'd like to have your thoughts on that.
Yeah, great, thank you very much. Yeah, so I guess I've kind of got 2 points on this one in terms of where the gap is and relating to my message. So I feel that there was a quote that one of the speakers said yesterday, and I can't remember who the speaker was, I apologize, but I'm paraphrasing, and the phrase was that having sophisticated software and computational outputs, it doesn't remove the need for humans to interpret that outputs like some of our speakers here do as their day job. It's very hard to sometimes take an output from a piece of software and then realize what that actually means. So user inputs, the abundance of data coming out of softwares and things like that, it all requires sometimes one or two people with a very clear vision to make sure that's constantly delivered. The second point on this is whenever a design leaves our offices, or any of the speakers here today, when a design leaves their offices, it goes down to the people on the ground to deliver. And sometimes they don't always get the memo that the construction detailing needs to have this particular little area, or that pipe must absolutely be insulated, or this panel must absolutely be this size away. And sometimes there's construction cultures we have to address top down. But also there is points in the middle where sustainability gets cost optimized out of things altogether. So whenever it leaves, the design leaves a sustainability consultant or an architectural technologist, and it goes to a quantity surveyor, and they're interacting with the client, and then the heat pump is this much more expensive than an oil boiler, or this sort of insulation, hemp insulation or lime insulation, or some of the natural handmade stuff is more expensive than the petrochemical stuff. The client and the QS then just start to pull that out, and then you start to see a race to the bottom for cost of housing. So there's an education element there for those who deliver costs for mass house building. And in terms of what we're missing, it might just be a kind of bottom-up culture where we shouldn't be driven by costs. We should be driven by local resources, be driven by local handmade materials, local. So for example, in Scotland, we've lost a lot of trades around thatch roofs, around sandstone walling, around mass walling for hempcrete and things like that. it should be more of a local bottom-up education for us at the top, and also a bottom-down education for those involved in costing. It's no longer appropriate to pull out a particular material or technology just because there's a cheaper, often nastier alternative. That's my take on it.
Thanks, John. So it's value engineering. We see it every day happening in practice, and it's it's a reality. So we have to see how we can kind of deal with it. And like you mentioned, awareness, education is really key. So that brings me to Dr. Karan Obedi. So you're trying to educate the future designers who be out in the field and be industry ready and be able to deal with this value engineering and this communication gap and so on. So what do you think, in your mind right now, the challenge in actually reaching out to students and making them, you of course, all your work was reflective of how you're trying to bridge the gap, which must have taken a long time. It's not something you've achieved, in a very short span of one semester or something. So your thoughts on it?
Thank you so much. Actually, there are many factors, especially I can call it from my understanding and my view at education level, and especially after that when we are engaged with the industry. Even with the complexity of the software, for example, still there are limitations. Still the type of simulation or the tools that we are utilizing, they're not quite dynamic, I can call it. They're still static. They are for specific dates or for specific time. They are not running, for example, even they're running for a whole year, but the accuracy there is still not that kind of 100%. So this kind of one of the limitation, can call it, with the software, even with the complexity. Second part, the aspect also, the knowledge and the people who actually are handling this kind of software and simulations. So now we have a different type of, I can call it, backgrounds or expertise. Either they are engineers or they are architects, architectural technologists. Each kind of fields, they have a kind of a different understanding of handling or mastering this kind of like a tools. So the outcomes and the errors that could be expected, that will really affect on the outcomes of the design. Other things related, also the things mentioned by John and also by Sophie, which is about the cost and the communication. There's still this kind of like a problem there. There's also an issue related to the energy. We put a lot of high expectation about renewable energy and utilizing solar panels or wind energy or biomass, but still actually in the reality, we are lacking to get a full support because of the policy or because of the regulations. Also, there's another things I could see is for example, many buildings awarded or they received outstanding performance on excellent building during this design stage or during maybe the first years of operation. But the problem, there are a lot of issues after the running or after the operation stage. And currently there are many issues and many research, we call it post-operation stage, to be conducted and to be studied. So we are offering that kind of opportunities to outside, all the buildings, the clients or the architectural firms. But there's a kind of like issue in the future, after 2, 3 or 4 or 5 years, what's the aspects of durability or the sustainability? This is kind of an area still under exploration, and really not a lot actually of research to get a feedback and support about this kind of like an view. I think what I could call it and supported by to answer actually the question that you asked, sorry.
Thank you. So, yes, of course, we design it with the full intent of meeting the goals, and then during operations, it kind of takes another story. It would have been nice if Dr. Chalal would have been there, because all his focus was on existing buildings and users. The tools, etc. Yeah, of course, like you said, it also needs its own kind of cycle of development. So it becomes like this complete entity that you can rely on, the end-to-end kind of a solution that a tool could give potentially in the near future.
And I think one of the approaches currently now, even with architectural technology, is to explore this kind of like a field, is to get this kind of support from engineering and to get support from architecture and to get support by understanding as a scientist to this kind of like of an aspect. So we hope within the future, with actually the movement of architecture technology and development in this field, is to really provide a very strong impact, on the design or on the building to support architects or even, designers, specialists outside.
Thank you. So, this brings me to Dr. Mark. You opened the day, like the session today so beautifully saying that technology can actually become a partner, and digital design is a way of thinking about design. And now we heard different perspectives of how, communication gap is real, cost cutting is real, problem of plenty when it comes to tool is real, and becoming moving towards very, very complex solutions is real. So just your thoughts on, you showed so many examples of virtual reality where it can give the users and the designers such an immersive experience which no physical tool can actually give. And how do we, your thoughts on this gap, and is it too much that we're just jumping the, steps to get to virtual reality?
Yes, probably I was a bit provoking with the whole virtual reality and the possibilities which one can do, and partly have is very distant to reality. Architecture is, I think, a very slow-moving process. The education is very slow-moving. The building process is also very slow-moving. From the idea that you want to do something until it's then realized is really a year-long or several year-long process. And I would actually argue that architecture is at the end of the food chain of technology development. So the technology has to be developed in the first place before it can be applied in architecture. So there is a long time before the technology is developed, and then the other time before that can find its way into the architecture, into a building process. Other industries are much quicker, much faster in their turnaround time. Now and that's where I now come to the virtual experience, that can have a certain frustration when you engage in architecture, that you do something until it goes there, or you have a idea, or it is so multi-layered that you can't really express where you want to go. Now, in a virtual environment and playing with these instruments, it allows for a very quick solution. I have an idea, I can test it, and I can explore that. And by that, it gives a certain, I want to say nearly hope, I can actually achieve something, I can actually influence something, and I see how that comes to an outcome. And with that, sort of instilling this idea of a narrative and the idea that I can influence things, that I hope that it translates then in the construction industry, where you become a small part in a larger thing in a very long time span, that you say, okay, I can contribute and I see where my narrative is, and by that form then the overall process.
Right, so basically we need to have some patience and kind of immerse ourselves in this slow kind of process, because that's how it kind of is in the nature of how design is.
Right.
Yeah, so like you said, like automobile industry has a very quick turnaround time catching up with technology, unlike the building construction industry or the design community as such. So as we are in the topic of technology and this whole immersive experience, I now go to Dr. Amardeep Dugar. I think you are here. I couldn't see you yet.
Can I ask a question before actually you go to Amardeep? This is like, I see Mark and Varun right, top. I mean, Mark is sitting on top of Varun in my screen. Mark is talking about virtual reality and Varun is talking about reality. And what is the truth? I mean, I just wanted both of these guys talk a little bit about it. Where is the reality? Where is the reality lying? I mean, he's talking about doing things by hand, in real, in actuality. But this guy is actually lying down, facing the floor, and he's exactly, he's just seeing everything, Now, where are we in this? As architects, what kind of a middle path we should take from reality to virtual reality, where are we going? I just, it came to my mind. I did not write this question. I mean, if
Right.
Mark and Varun can sort of talk to
Right,
each other,
yes.
good.
No, I think as an architect, you always work in that realm between the virtual and the reality. You have your idea, you work with your team, you be dependent on lots of things. The real building is at the very end, the outcome. But until you get there, you have all these, it's basically virtual. So you develop your idea from the perspective of, no, you develop your idea from, you want to have something real, but you work from a virtual towards a real. And that's a very interesting, I would say, environment you work in, because the outcome and how your building actually performs, how your building is at the very end after you completed the whole process. So you can actually learn only in the next process of what you did in the first one. But the next one is often a very different project. So I think it's a very interesting realm in which we work, because it's very hard to pin us down.
Varun, your thoughts?
Well, until 2013 or 14, I was an extensive BIM user. I used to write VB scripts for automation of the industry. And somehow, there was this kind of revelation that just happened, where I really had to look at myself and what was I going to do. When I was this BIM specialist, or coordinating between people, I realized that the architect had just come down to becoming a salesman of products driven by the industry. And that was a very pathetic kind of a role to play. It's like a medical representative where the medicine's always changing and the diseases are always changing. And the rep is just there bridging the gap in between two. And that is not what architecture was. When Pippo Brunelleschi, I'm just using domes because I'm really just trying to put this in context. I can talk about other technologies as well. But then architecture was about imagining spaces, feeling spaces in the real, and transferring those visions, those ideas into something that people can very easily understand. People would make a physical model of it. Sometimes they would construct a 1:10 real model of it before building it. And in Brunelleschi's book, they talk about this setting up of a 1:10 scale dome, and the building of the dome on Santa Maria del Fiore, how people would be able to come and look at it. It's real. It's right there. It's accessible, and it's a very simple idea that someone can understand. And this drive towards the virtual somehow has got into even all my students. My interns come in with laptops with 100 softwares installed, and I just pack them off and say, you just have to sketch and draw and imagine and experience and feel before you can even get onto the communication of your own feeling. That's a very powerful thing. If you're not able to feel what you're working with, the people you're working with, what is it that you're communicating?
Yes, Jafar, so you have anything to comment? Or?
Yeah, I think this is an interesting argument that I would have expected out of this conference, actually, reality versus virtual reality. And I'm very keenly interested. I'm a traditional architect myself. So I graduated in the year 1983. I became totally illiterate in 1995. when I went to a conference and I found that I did not know how to use a computer. So I came back and started my computer studio in 1995. Since then, my studios have been fully computerized. But I have not been trained as a computer specialist, but I've had people working for me using computers. But I think Varun has got a lots of things, which talks about reality. It's all architecture is all about reality. It, it can be, it can have a process where a virtual reality can be just a part of it. But end of the day, like if you look at some of these projects done by Zaha, for example, Maxi Museum, or for that matter, look at the sketch, what she did. Just a sketch she just roughly did, and from the sketch it transforms into a three-dimensional virtual model, and then the reality. So it's actually that sketch which transforms into reality. And what Varun was doing is that sketch which is transforming into reality. And how does that virtual reality fit in there? Will it get the exact feeling when I go to Sydney Opera House? How do I feel when I go to National Theatre in London? And I love to go there because I love to touch the concrete done by Dennis Laston. But how do I get when I get to Grace Academy? Okay, Grace Academy is a good building. But say, for example, those funny buildings done by Patrick Schumacher. Sorry about that, it's a public thing, but Patrick is my good friend. So how do I get that feeling there? Do I get the same feeling when I look at this? The intense reality of Varun Thautun's work. It's reminding me of Architecture for the Poor by Hassan Fathy. Unfortunately, I just missed meeting Hassan Fathy those days. But this is something which is real. But of course, his work has certain limitations. But we are talking here about how virtual reality can bring in that real feelings. Does those feelings sustain for a longer period of time? Varun's work, once I see it, it's deep into my head. But if something which is in virtual reality, it's there, I enjoy, and just forget it, gone. It's out. It's not part of me, no more. But this is something which is part of me because I love to see it, I love to touch it, I love to embrace it. Where is that feeling in virtual reality? And this is the argument which will go on. I'm a technologist. I love to land in Mars. If this guy SpaceX wants to take me, I'll love to go there, definitely. But anyway, we're going to spoil Mars and we're going to destroy it anyway in future. So this is the argument that we need to have. This is the argument the schools of architecture need to look. Reality versus virtual reality. Which is real in this? This is the argument we need to have. It's all about drawings, making drawings, supplying the drawings, production drawings, giving it to them. All that is there, but the students have that, the inner question within them. We teach them about architecture. We teach them about what is real architecture. Okay, I'm talking about ethics in my class for my students. When they go out, what kind of ethical society they're going to face. I'm going to teach them architecture. I'm going to teach them virtual architecture. What is the are they really building anything in my school? Okay, they may be making perfect drawings. Are they really building anything? These are certain things that should come out, and it should be argued upon and at least discussed or deliberated. Sorry it's been too long.
Yeah. No, I hear you, and what you say is stuff definitely right. On the other hand, one cannot compare the one medium with the other. The virtual is something very different, and there's nothing worse than a bad copy. It is the same in reality, and it's just translate to virtual. So if you copy something in a virtual context, it is not the same. The same thing is if you have something in the virtual and you bring it in reality, it is also not the same. A sketch is also not the building. It is an expression of what the building is. So the experience of going to the actual building cannot be replaced by any other medium. on the other hand, the sketch can convey something and can bring an essence together, which brings the idea or the complexity of a building to a very to the point. And I think that can be the same thing in a more virtual environment. It can bring an experience and it can pair a narrative to the point, which is not the copy of the reality, but it is its own right, an expression of what you as an architect, as a designer want to convey.
Thank you. I see Boris. Sorry, I see Mr. Boris Saranik kind of raised hands. He was a speaker yesterday.
Yes.
And then over to you.
Thank you. Can you hear me, by the way?
Yeah, we do.
Oh, great. Well, just a very, of course, Jaffa is very right. This is a very important conversation, one which we have actually started yesterday. Interestingly, which goes to say that it actually supports the importance of it, both in terms of how we teach architecture, but also ultimately how it will have an impact on the practice in the future. And I mean, I really enjoyed both of these, and I always have been, and never looked at those things as a reality versus virtual reality or analog versus digital. I just remember back in 90s being lucky to work very closely with my fine art colleagues when the computers were really novelty. I remember one of my fine arts colleagues working on on this sculpture, and with what ease and not even rational thinking she was moving between the sculpturing and working on the 3D model on their computer. It really amazed me. She did not have any problem exploring the physical and analog at the same time. It just came to her as another creative playground. As much as you can creatively play within the analog, you can also play within the digital. It's a medium. It's not there to constrain our creativity, but it's there to actually give us another place to explore it. So I think that's how I see that. Almost being excited by the hybrid between the two. Certainly in terms of education, never allowing the one overtakes the other or the one becomes the only one. So I agree with that, and I agree with Varun. Yes, of course, I think there will be very, very few educators that could not agree with the importance of learning by physically building something. I've done a couple of projects with my master students as well, but it's not always easy to organize, certainly in a country like the UK. You've got the health and safety, a million other things to think and worry about. And some of the things that Varun was doing with their students probably would be locked up in terms of health and safety in the UK, in terms of the rules and regulations. But nevertheless, we should support that learning by doing in all of its formats, and yes, ultimately culminating in actually building something, if not one-to-one scale, at least on large scale, so the students can kind of experience the two. But I think most important thing to me, I generally don't feel the tension between the two. I do get excited actually by the hybrid opportunities the two can offer.
Thanks. So we are running out of time. So what are your final thoughts?
No, thank you, Boris. Yes, I remember reading this Pillars of the Earth, a very nice book on how a design was communicated. But eventually, I really want to rethink architectural education. I think Europe has come a long way, of course, but Europe was all about building cathedrals and having students and apprentices and journeymen and master craftsmen traveling around building very large cathedrals, castles, working during wars, building big buttresses and whatnot. It was all hands-on. It was all very, very real. And somehow India is still very real, luckily. And a major part of our architecture education is very real. But I'm really wary that we don't have to go through this whole cycle of investing into lessons that We've already learned that something did not work. I wish I could come to Europe and teach. I've been invited in Spain to come and do a Walt and Dome workshop. Those are Boris, as Boris rightly said, those are the exact challenges that we had to face. And why not? Nobody was hurt in any of my workshops.
Okay, I'm now taking over briefly to summarize. I am not an architect. I'm interested in architecture. I'm interested in Imagineering and creativity, but through obviously architectural technology. And I've been around a long time, and I've seen the changes in architectural technology, and particularly applied to the optimization of building performance and building production. The optimization of building production is not something new. If we look back to 1940s in the UK, in the United States of America, there was a lot of work.
Professor Sam, you've gone on mute.
You're on mute.
Good, lucky me. Anyway, I don't know where I was, but anyway, talking about optimization of production. If those are the two strands of architectural technology, are designing for production, designing for performance, and utilization of technology to help optimize both. The production side, I say, is not new. And if you look back to William Levitt in the United States of America in 1940s, he was mass producing housing for the return of the American forces after the Second World War. And he managed to design a process and reduce the construction of that building down to 27 steps. That was before technology. And this is where we're missing a trick. We are not using technology to optimize the process of construction, from materials and components to be manufactured, to be assembled, to minimize waste, to make them energy efficient, etc., etc. There's a long way to go on that. I don't see much of that being taught at all in architectural technology schools or architectural schools. Yes, I see a lot of focus on the performance, and many of the presentations today were excellent and did focus on performance and the technology linked to the environmental performance, be it lighting, be it energy efficiency, etc., etc. But I say we've still got some way to go and how we marry these two things together. And certainly, again, in my life, as I come to the end of my, certainly I'm beyond the end of my professional career, but you know, when I look back in the changes, it's a bit like the medical profession and for that matter, surgery as well. When you look at the technology now that's being applied in medicine, the technology, the same needs to be applied to design, and not necessarily see a technology as we're a slave to technology, but how we can utilize that technology in so many different ways, both in terms of designing that production, designing for performance, but as many others have said today, it's about people use buildings and how people use buildings. So what I've noticed also is the impact of technology on education is significant, and very pleased to see certainly some of the good presentations today, particularly one looking at education. And I think what we have to all learn is it's not one size fits all. It's not a singular eye profile. I think we need to think about educating our younger generation, our younger students, in terms of T profiling. And the T profiling allows people to always have that bar across the top, that breadth that you can always return to when you drive that deep furrow. We don't want eye profile people because they're very narrow. Yes, we do need eye profile people, but not for the kind of roles and functions that we have in architectural technology, be that in architecture or architectural technology. And then moving forward, as you progress your career, you become a star profile. And I don't necessarily mean you become a star, but you're in the middle, as like Sophia Key pointed out, just to demonstrate the range of knowledge and skills that she had to have to operate and function properly to deliver a project, you know, on time, at cost, and given quality. So it's extremely interesting, and that's what certainly I could never have predicted when I look back in terms of my career in architectural technology, is now the impact of technology on design, on construction, and on use. And certainly for you guys and the younger generation, use it and don't abuse it. And that's where I will end. Thank you.
Thank you so much, Professor Sam, for those wonderful words. I now call Professor Meenakshi, the co-convener of this webinar, to have a couple of last words before we wrap up the session.
Good evening from India. And I don't know, I am actually falling short of words at the type of knowledge that was shared in today's platform is really humongous. I really like the way the virtual reality versus reality actually had. And I really want to point out a few takeaways from today's session, starting from our keynote speaker today, from Mac Oral, and I really loved the way his contact lenses actually shows a different virtual world to us. Yes, it was a little exaggerating, as you said, but yeah, that's what we are looking at. That's what technology is actually moving very fast in our lives that we've seen in last 3 decades now, and the advancement is quite fast. We can't agree less with you in that. And from there, we went to Dr. Morrell, who actually showed us how carbon emissions can actually be calculated, and also how he actually took the feedback from community feedback to develop eco-friendly apps which can actually integrate with academics, and how he can actually develop a better environment solutions. And his mixed method research methodologies were really eye-openers for us. His platform actually, while he was presenting, it actually, the next presenter, which Varun Thotam, when he actually showed his simpler way of construction, we actually understood how technology versus reality was actually can be integrated together in making academics a better platform to learn. For that, our speaker, Mr. John, actually showed us how environmental apps were developed and how they were being integrated in environment and ecological studies. And then followed by our Karam Ali Olis, who actually showed us his teaching integration with industrial implications and to enhance the need and complexity of the technologies in the architecture technologies. Yes, we can't miss out on how I'm going to say Dougal actually faced up a new dimension to our entire talk with his lighting fixtures as an element of architecture itself. He also pointed out very rightly in the end, stating that the integration of evolving of lighting techniques in the building industry need to be more environmental friendly in understanding the spatial concept, which is at the experimental level. I really appreciate the parameter that he has brought in into discussion. That's a really different parameter, but it's really need of the hour when the lighting industries technologies are so fast integrating into our daily lifestyle. LEDs have become a part of our life now. And we also study a lot of damage over the night sky that has been happening because the effects it is causing on the environmental side is discussed further. And yes, has also integrated of digital technologies with daylighting. And Sophie also told us what the challenges that she was facing in integrating different types of technologies in the client required parameters. And I think as our moderators rightly started on the right question, actually, where they actually asked how to integrate technologies into construction industries. Deepa Parekh actually right question. I was surprised that the question was so apt to the discussions what we had in the beginning, and the way actually added up with how the technologies were given exact sizes, integration of how the technologies can help in optimizing the right amount of services, right amount of energy consumption, but how we are still in the experimental level, and how John actually told us that how his experiments are actually still giving us a new dimension every time he took an experiment, and how his energies were not efficient, but it was consuming more. Yes, I think when the technologies that were talked, like VR and the experiments that were done, the feedbacks, the eco-friendly feedbacks that were taken, these all are actually guiding us to a different multi-dimensional level, which actually quantifies with the reality that we need both virtual reality and the real reality hands-on exercises, as Mr. Boric has rightly pointed out, saying that we need an hybrid integration of both to move ahead in this present scenario. I really want to thank all our speakers to share their valuable inputs and actually opened up a lot of platform for our academicians and practicing architects, and enlightening our students to think that the world outside is actually an hybrid world that they're going to get in. They have chances to learn, move ahead, and create and play a bigger part in the world ahead. Thank you, speakers. Thank you so much.
Thank you, ma'am. Thank you, Professor Sam and Architect Deepa, for making the panel discussion so fruitful. I thank all the panelists for their valuable thoughts on the influence of technology in the built environment. It was quite enriching to listen to each one of you. I couldn't thank Dr. Mark enough for being here and sharing all those wonderful thoughts and ideas on virtual reality. Thank you, everyone. We'll meet you again tomorrow for the third day of this international webinar. Have a great rest of the day, everybody.
Thank you all.
Thank you very much.